From Einstein's theory of relativity to the mind-bending mysteries of quantum mechanics. From the explosive origins of the Big Bang to the eerie invisibility of dark matter, these ideas are not just theories. They're gateways to a universe beyond imagination. But what if there's more? What if our universe is just one of many? Or brace yourself, what if we're all living in a simulation? Embark with us on a journey to uncover the universe's greatest mysteries, diving into mind-bending theories that will expand your imagination. Together, we'll travel through the cosmos, unlocking the secrets of existence. Theory of relativity. Developed by Albert Einstein in the early 20th century, this theory reshaped our understanding of space, time, and gravity. It's divided into two parts: general relativity and special relativity, each revealing unique insights about the universe that continue to shape science today. Let's dive into general relativity, introduced by Einstein in 1915. Unlike earlier concepts of gravity as a force acting across space, general relativity describes gravity as a result of curvature in the fabric of space-time. Picture a stretched-out trampoline with a heavy ball in the center. The weight of the ball creates a dip, causing smaller objects to move toward it. In the same way, massive objects like stars and planets create similar dips in space-time, which draws other objects toward them. This is how general relativity redefines gravity as the bending of space and time itself. This idea of space-time as a four-dimensional entity where mass and energy can cause a curvature was groundbreaking. The closer an object is to a massive body, such as a planet or a star, the stronger the gravitational effect it feels due to this curvature. In 1919, general relativity received its first experimental confirmation during a solar eclipse. Astronomers observed that starlight passing close to the sun was bent, just as Einstein had predicted. This phenomenon, known as gravitational lensing, occurs because massive objects, like the sun, bend the space around them, causing light to follow a curved path. Today, gravitational lensing remains a valuable tool in astronomy, allowing scientists to study distant galaxies and even detect objects that would otherwise be invisible. The implications of space-time curvature are profound. For example, in areas where mass is exceptionally dense, such as in black holes, space-time curvature becomes so intense that it collapses into what's known as a singularity, where gravitational forces become infinitely strong. At a singularity, Einstein's equations in general relativity also hinted that the universe could not be static, eventually leading scientists to discover the expansion of the universe and support for the Big Bang theory. This concept is foundational in cosmology and helps us understand the vast structure of the universe. Moving to special relativity, which Einstein introduced in 1905, we encounter another revolutionary idea. The speed of light is constant, regardless of the motion of the observer or the light source. Special relativity specifically applies to objects moving at constant, non-accelerating speeds and fundamentally changes how we understand time and space. According to this theory, as an object nears the speed of light, time slows down for it relative to an outside observer. This phenomenon, called time dilation, has been observed in experiments where fast-moving particles and clocks flown around Earth experience measurable time differences. For example, GPS satellites in orbit need corrections for time dilation to maintain accurate navigation on Earth. Two critical concepts arise from special relativity: time dilation and length contraction. Time dilation means that time slows down for objects moving at high speeds. This could theoretically allow for long-distance space travel, where astronauts could experience only a few months while years pass on Earth. Length contraction, on the other hand, states that objects in motion appear shorter in the direction they are moving. This effect is only noticeable at speeds close to the speed of light, making interstellar distances appear shorter for high-speed travelers. Together, these concepts reshape our understanding of time, space, and even the feasibility of human space exploration. One of the most famous outcomes of special relativity is the equation E equals mc squared, which reveals that energy is equal to mass times the speed of light squared. This equation implies that mass and energy are interchangeable, meaning that even a small amount of mass can release a tremendous amount of energy. This principle forms the foundation of nuclear energy and explains why stars emit so much light and heat through nuclear fusion. In nuclear reactions, tiny amounts of matter are transformed into vast quantities of energy. This equation also led to predictions about antimatter and other exotic forms of matter, enriching our understanding of particle physics and cosmology. Despite its success, relativity isn't without challenges. General relativity, which describes large-scale phenomena like stars and galaxies, doesn't align well with quantum mechanics, which governs atomic and subatomic particles. The pursuit of a unified theory that combines both realms, often called the theory of everything, is one of the biggest goals in theoretical physics, with approaches like quantum gravity and string theory attempting to bridge this gap. Furthermore, general relativity's predictions about black holes and singularities hint that our understanding of space-time might still be incomplete. Observations of phenomena like dark energy, which accelerates the universe's expansion, suggest there are aspects of physics yet to be discovered. Though it may seem abstract, relativity has practical applications in everyday life. For instance, the Global Positioning System, GPS, relies on relativity-based adjustments, as satellites orbiting Earth experience different gravitational and speed effects on time. Without these adjustments, GPS accuracy would quickly degrade. Relativity also plays a crucial role in particle accelerators, which must account for relativistic effects as particles approach light speed. The Large Hadron Collider, for example, uses these principles to ensure the accuracy of high-energy particle physics experiments. In summary, the theory of relativity transformed how we perceive the universe by demonstrating that space and time are interconnected and can be influenced by gravity and motion. General relativity redefined gravity through space-time curvature, while special relativity reshaped our understanding of time, speed, and energy. Together, these theories form the backbone of modern physics and continue to inspire new technological and scientific advancements. But relativity is only the beginning. As we venture further into the mysteries of black holes, time travel, and the expanding universe, we may yet uncover even more mind-bending truths about reality. Let's move on to string theory, an ambitious and mathematically complex theory that aims to unify all of the fundamental forces in nature and provide a theory of everything. String theory suggests that the fundamental building blocks of the universe aren't particles like electrons or quarks, but incredibly tiny, vibrating strings. These strings and their vibrations supposedly give rise to all particles and forces, making string theory one of the most promising yet confusing approaches in modern physics. At its core, string theory proposes that the building blocks of our universe are one-dimensional strings. Each string vibrates at a specific frequency, producing different particles and forces, similar to musical notes on a string instrument. For example, an electron and a photon would both be different vibrational patterns of a fundamental string, much like different notes produced by the same string on a musical instrument. One of the revolutionary aspects of string theory is its potential to unify quantum mechanics, the physics of the very small, and general relativity, the physics of the very large. While quantum mechanics explains the behavior of particles and relativity explains gravity, these two frameworks are currently incompatible. String theory could provide a way to reconcile them by offering a single, coherent framework that accounts for all known forces and particles. Multiple versions of string theory emerged in the 1980s, leading to confusion. However, physicist Edward Witten introduced M-theory, uniting these versions into one overarching framework. M-theory suggests that strings may not be the only fundamental structures. Higher dimensional objects called branes, short for membranes, might also exist. These branes could be as small as a single point or as vast as a universe, adding a whole new layer of complexity to the theory. According to M-theory, our own universe might be a three-dimensional brane floating within a higher dimensional space, possibly interacting with other branes and universes. One of the most challenging and mind-bending aspects of string theory is its requirement for additional spatial dimensions. In everyday life, we experience 3 dimensions of space and 1 dimension of time. However, for string theory's equations to work, 10 or even 11 dimensions are required. The additional dimensions in string theory are hypothesized to be compactified or curled up so small that we can't perceive them. Imagine a two-dimensional sheet of paper curled into a tight spiral. If you zoomed out far enough, it would appear as a one-dimensional line. In a similar way, the extra dimensions in string theory could be curled up to scales smaller than an atom, making them invisible to us. The idea of extra dimensions, while mathematically sound, is almost impossible to visualize, adding to the confusion and intrigue surrounding string theory. These dimensions could hold the key to understanding forces that seem weak or mysterious in our familiar dimensions, such as gravity. Because string theory allows for many possible solutions, there may be an enormous number of vacua or possible configurations of the universe. Each configuration would correspond to a different set of physical laws and constants, leading to the possibility of a multiverse, an immense collection of universes, each with its own distinct properties. In other words, our universe could be one among countless others, each governed by different rules. This idea is both intriguing and problematic. If the multiverse is real, it would be impossible to test or observe directly, meaning we may never confirm or falsify its existence. Critics argue that this makes string theory difficult to treat as a true scientific theory, as it may lead to predictions that cannot be tested or observed. Despite its promise, string theory faces challenges. It lacks testable predictions, is mathematically complex, and some question if it qualifies as a scientific theory due to its non-falsifiable nature. Even without concrete proof, string theory has profoundly impacted physics and mathematics. Concepts from string theory have influenced quantum field theory and pure mathematics, leading to insights that extend beyond its original scope. Physicists continue refining string theory, hoping that future experiments or new technology will reveal supporting evidence. String theory offers a path to unify all fundamental forces, potentially revealing a theory of everything. Whether it leads to a revolutionary understanding or paves the way for future theories, string theory marks a bold step in our quest to unravel the cosmos mysteries. Approximately 13.8 million years ago, an enigmatic occurrence propelled the universe into motion, marking the advent of the Big Bang, an extraordinary event that gave rise to every atom, star, and galaxy. However, what unfolds here is uniquely ours, a saga spanning millennia where we've endeavored to construct a vision of the universe. This endeavor, guided by the principles of science, has allowed us to fathom our place within the vast cosmos. Over thousands of years, we've documented our celestial observations in volumes that could easily populate a library. The edifice of knowledge we've erected regarding our universe encompasses its origins and contemplates its eventual conclusion. So where does our narrative commence? Let's embark on this journey from the very outset. Let's delve into the genesis, starting with the monumental event known as the Big Bang. The concept of the Big Bang serves as a framework for understanding the cosmic evolution and unfolding narrative that illuminates how the universe transformed in the blink of an eye. The very nature of what sparked this cosmic genesis remains an unsolved puzzle to this day. As we peer into the vastness of the universe and contemplate distant galaxies, a mesmerizing panorama unfolds. Everything appears to be receding from us, propelled outward at astonishing speeds. We string that all the way back, we glimpse a singular moment, perhaps 13 or 14 billion years in the past, where all matter was inexplicably condensed into an inconceivably dense point. The Big Bang stands as our prevailing theory, a testament to our attempts to decipher the universe's inception. For an extended period, contemplation of the universe's origin was not a common pursuit. Some didn't dwell on it, while others assumed the cosmos had perpetually existed, an everlasting entity shrouded in mystery. Initially, even scientists hesitated to embrace the concept of the Big Bang. Originally intended as a somewhat derisive term, the name itself poses a paradox. It wasn't particularly big, considering our belief that the universe originated from a singularity, and there was no literal bang since there was no air to transmit vibrations. Today, the Big Bang Theory is a well-established pillar of science, widely accepted and understood. However, acceptance and comprehension are distinct realms. While the Big Bang Theory has solidified its place in our understanding of the universe, it hasn't yet unraveled all the mysteries science seeks to answer about the birth of our cosmos. Conventional Big Bang Theory remains silent on what triggered the bang, why it occurred, or what transpired before it. At this very moment, we find ourselves in the aftermath of the Big Bang. Everything what we see and hear and taste and smell and touch is aftermath. This is the Earth, a marvel of silicon and oxygen encasing a metallic core. Its surface is dominated by vast oceans, fostering a diverse array of life. In a rhythmic dance, the Earth completes a full rotation every 24 hours while encircling the radiant star known as the Sun, completing an orbit every 365 days. The Sun, a radiant giant predominantly composed of hydrogen and helium. With a scorching surface temperature nearing 10,000 degrees Fahrenheit, this cosmic powerhouse converts a staggering 700 million tons of hydrogen into 695 million tons of helium every second. This celestial luminary is at the heart of our solar system, which took shape approximately 4.5 billion years ago. This system has 8 planets, from the sweltering Mercury to the frigid Neptune. Our solar system is no static entity, hurtling through space at a staggering 134 miles per second. It is part of a vast congregation of stars and stellar systems. This congregation, known as the Milky Way galaxy, around 200 billion stars. Among these, an estimated 6 billion may harbor planetary systems akin to ours. Our solar system, orbiting the center of the Milky Way on one of its outer arms, is just one member of a grand ensemble. The Milky Way is merely one among the vast expanse of more than 125 billion galaxies, constituting the observable universe. Indeed, the universe is colossal, and its enormity continues to expand. If we rewind time, we can witness the universe contracting, shrinking from a cosmic scale to a galactic one, then to the dimensions of our solar system, and further still until everything is confined within the confines of a studio, a coffee cup, and ultimately an atom. The vastness of the universe unfolds before us, a cosmic narrative expanding across unimaginable scales. Physicists have pieced together an approximate timeline of significant events in the cosmos' existence using telescope data and models of particle physics. From its beginning to its inevitable demise, we examine key points in the evolution of our universe here. Cosmic inflation era. The next cosmic confab was to rapidly expand in size. The universe may have expanded exponentially after the Big Bang, tearing off previously colliding parts of space. This period, known as inflation, is still mostly theoretical, but it has gained favor among cosmologists as a possible explanation for the striking similarity between distant parts of space. Attempts to detect this expansion in light from the early cosmos were reported in 2014. Nevertheless, further investigation revealed that the true culprit was nothing more than interplanetary dust-causing interference. Quark-gluon plasma. The temperature of the early cosmos was between 7 trillion 10 trillion degrees Fahrenheit or 4 trillion and 6 trillion degrees Celsius, just a few milliseconds after the Big Bang. Quarks, elementary particles ordinarily contained within protons and neutrons, were free to move about at these temperatures. These quarks were combined with gluons, carriers of the basic force known as the strong force, in a primordial that pervaded the whole universe. In particle accelerators on Earth, scientists have replicated these circumstances. In both terrestrial atom smashes and the early cosmos, the challenging to achieve condition only lasted for a few fractions of a second. The early epoch, the subsequent period of time, beginning perhaps in the neighborhood of a few thousandths of a second following the Big Bang, was a period of intense activity. The universe chilled as it expanded, creating an environment conducive to the merger of quarks into protons and neutrons. The cosmic neutrino background, which has not yet been detected by scientists, was created 1 second after the Big Bang, when the density of the cosmos decreased sufficiently for neutrinos to sail across space without interacting with anything. The first atoms, protons and neutrons, fused together during the first 3 minutes of the universe's existence, creating the isotope of hydrogen known as deuterium, along with helium and a trace quantity of the next lightest element, lithium. Yet, this procedure ceased as the temperature dropped. As temperatures settled down 380,000 years after the Big Bang, hydrogen and helium had free electrons to form the first neutral atoms. The cosmic microwave background, a remnant of this epoch first identified in 1965, was created when photons that had previously collided with electrons were able to be out without being disrupted. The Dark Ages. There was a lengthy period of time when nothing in the cosmos emitted any light. The cosmic dark ages refer to this time frame of around 100 million years. Because practically all of what astronomers know about the cosmos can be gleaned by studying starlight, this era remains exceptionally challenging to study. It's hard to piece together what happened if there are no stars to guide us. The first stars were formed when hydrogen and helium began to compress into massive spheres, some 180 million years after the Big Bang, creating hellish temperatures at their centers. After the neutral hydrogen atoms in interstellar space were broken apart into protons and electrons by the intense photons generated by early stars and galaxies, the cosmos entered a period known as cosmic dawn or reionization. It's hard to put a time limit on reionization. As it happened so soon after the Big Bang, its signals have been masked by subsequent gas and dust. Thus, the most that scientists can determine is that it was finished by around 500 million years after the Great Bang. Large-scale structure. Almost a billion years after the Big Bang, supermassive black holes developed at the cores of merging early galaxies. Intense quasars, visible from 12 billion light-years away, switched on and began emitting their bright beams of light. The universe's middle years. Throughout the subsequent few billion years, the cosmos underwent more evolution. Denser regions in the early cosmos drew more material due to gravity. A gorgeous filamentary cosmic web is the result of them slowly expanding into galaxy clusters and lengthy strands of gas and dust. Birth of the solar system. A yellow star with rings around it formed from a cloud of gas around 4.6 billion years ago in one galaxy. These accreted rings eventually became the 8 planets of our solar system, as well as numerous comets, asteroids, dwarf planets, and moons. Either the third planet out from the Sun retained a lot of water via this process, or it received a deluge of ice and water from comets later on. Earth and humanity. Little, primitive bacteria appeared on that third, watery world between 3.8 and 3.5 billion years ago. These organisms arose and progressed into amazing marine monsters and enormous dinosaurs that fed on leaves. Some 200,000 years ago, upright beings emerged, capable of contemplating the vastness of space and learning about the universe's origins. The end or not? It isn't the final chapter, of course. The future of the cosmos is still a mystery to physicists. It is dependent on our ability to accurately quantify the characteristics of dark energy the unknown factor thought to be accelerating the expansion of the universe. All the stars in all the galaxies will have burned out, and even black holes will evaporate into nothing if the universe continues to expand forever, leaving behind a lifeless cosmos saturated with inert energy if this scenario comes to pass. Alternatively, the Great Crunch, a reversal of the Big Bang in which gravity triumphs over dark energy's expansionary force, will occur. The Great Rip, in which the cosmos rips itself apart, is another possibility if dark energy accelerates everything apart to greater and greater distances. Now, let's explore the next mind-bending concept: quantum mechanics. This theory explains the behavior of particles at microscopic scales, where classical physics no longer applies. Quantum mechanics introduces us to a world governed by probabilities, uncertainties, and phenomena that challenge our understanding of reality. One of the cornerstones of quantum mechanics is wave-particle duality, which suggests that particles like electrons and photons can behave both as particles and as waves. In the classic double-slit experiment, particles fired at a barrier with two slits create an interference pattern, behaving like waves. However, if we observe which slit each particle passes through, they act like particles again, as though the act of measurement changes their behavior. This mysterious link between observation and reality questions the very nature of existence. Next, we have the uncertainty principle, proposed by Werner Heisenberg in 1927. It states that we can't know both the exact position and momentum of a particle at the same time. The more precisely we know one, the less precisely we can know the other. This isn't due to measurement limitations but is a fundamental property of quantum particles, adding an element of randomness and unpredictability to the quantum world. Imagine you have a ball moving along a path. In classical physics, you can measure both its speed and position accurately. However, in quantum mechanics, if you try to measure an electron's exact position, you inherently alter its momentum, making precise measurement impossible. Quantum superposition takes uncertainty a step further. It states that particles can exist in multiple states simultaneously until observed. Erwin Schrödinger famously illustrated this with a thought experiment: Schrödinger's cat. Imagine a cat in a sealed box with a vial of poison. If a radioactive atom decays, the vial breaks, killing the cat. Until we open the box, the cat is in a superposition of being both alive and dead. This paradox highlights how observation affects outcomes in the quantum world. Superposition has practical applications, especially in quantum computing. Quantum computers utilize qubits, which can exist in multiple states at once, allowing them to perform vast amounts of calculations simultaneously. This gives quantum computers the potential to solve complex problems far beyond the reach of classical computers. Quantum entanglement is one of quantum mechanics' strangest phenomena. When particles become entangled, the state of one instantaneously affects the state of the other, no matter the distance. If we measure one particle, we instantly know the state of the other, even if they're light years apart. This phenomenon, called spooky action at a distance by Einstein, challenges the idea that objects are only influenced by their immediate surroundings. Entanglement has significant implications for quantum communication and cryptography. The Copenhagen interpretation, developed by Niels Bohr and Werner Heisenberg, suggests that quantum systems exist in superposition until observed, causing them to collapse into one definite state. This raises profound questions. Does reality depend on consciousness? If observing a particle can change its state, what role does our mind play in shaping the physical world? This interpretation bridges physics with philosophical debates about the nature of reality. In contrast to the Copenhagen interpretation, the many worlds interpretation proposes that all possible outcomes of a quantum event actually occur, each in a separate universe. For example, in Schrödinger's cat experiment, one universe would have a live cat and another would have a dead one. The many worlds interpretation implies a multiverse of branching realities, each representing different outcomes, avoiding the need for wave function collapse. While it sounds like science fiction, this interpretation has gained popularity among physicists. Quantum mechanics has led to groundbreaking advancements in technology, especially in computing, cryptography, and telecommunications. Quantum computers, for example, use qubits that can represent both 0 and 1 simultaneously, enabling them to solve complex problems much faster than classical computers. Quantum cryptography uses entanglement to develop unbreakable encryption methods. Quantum teleportation, although not teleportation in the science fiction sense, uses entanglement to instantly transfer information, potentially revolutionizing secure communications. Quantum mechanics presents philosophical and scientific challenges that stretch beyond physics. Unlike the deterministic world of classical physics, the quantum world introduces probabilities, where outcomes depend on observation, challenging ideas of objective reality. Quantum mechanics has inspired numerous interpretations and debates. Is reality independent of observation, or does our consciousness shape it? These questions bridge the realms of science and philosophy, making quantum mechanics one of the most existentially provocative theories. To summarize, quantum mechanics defies conventional understanding with concepts like wave-particle duality, uncertainty, superposition, and entanglement. This theory challenges classical physics, introducing a probabilistic and interconnected universe that pushes the boundaries of what we know. Quantum mechanics has paved the way for technological breakthroughs in computing and cryptography, yet leaves us questioning the nature of reality itself. As we journey deeper into these mysteries, quantum mechanics will continue to shape our understanding of the universe and invite us to rethink reality. Have you ever wondered, what if your life wasn't the only version of reality? What if, somewhere out there, there's another you living a completely different life, making different choices, following different dreams? Is this just a thought experiment, or could it be real? And if it is, how does that change everything we know about existence? In this journey, we'll dive into the science and philosophy of parallel universes, a concept so vast and mysterious that it might just redefine what we think reality is. Imagine this: somewhere far beyond the limits of our perception, there exists another version of you. Not just one, but countless versions. Perhaps in one reality, you're an artist creating breathtaking masterpieces, and in another, you're an explorer charting the unknown. It sounds like the stuff of science fiction, doesn't it? But what if it's more than just a story? What if the idea of parallel universes isn't fantasy, but a possibility rooted in the very fabric of our universe? For centuries, we've believed that reality is singular, one timeline, one set of events, one you. But the concept of parallel universes challenges that belief entirely. It suggests that reality isn't a single thread, but an endless web with infinite possibilities unfolding simultaneously. Think of flipping a coin, heads or tails. Now imagine a world where both outcomes happen, each in its own universe. It's hard to wrap our minds around, isn't it? But here's the real question: if these universes exist, where are they? Why can't we see them, touch them, or prove they're real? And if they are real, what does that mean for us, for our understanding of existence itself? It's a mind-bending idea, one that forces us to rethink everything we thought we knew about reality. And to truly explore its depth, we must turn to the science, where some of the most extraordinary theories suggest that parallel universes might be more than just a thought experiment. Parallel universes, what do we actually mean by that? Is it one big cosmic duplicate of our world, or something even stranger? The truth is, there's no single answer. Scientists and philosophers alike have explored multiple interpretations of what parallel universes might be, each more fascinating than the last. Let's start with one idea: infinite possibilities. Imagine every choice you've ever made, the roads you've taken, the words you've spoken. Now imagine every choice you didn't make, creating a new universe, a new reality where things turned out differently. Perhaps in one universe you decided to pursue your childhood dream, and in another you took a completely unexpected path. It's like a cosmic version of the choose-your-own-adventure story, where every option leads to a new chapter in an infinite book. Then there's the idea of alternate timelines. Think of history as a single thread running through time. Now imagine that at key moments, pivotal events in history, that thread branches out. What if, in another universe, dinosaurs never went extinct? Or if humanity never discovered fire? Entirely different timelines with outcomes we can't even begin to imagine might be unfolding alongside our own. But here's the twist: these interpretations aren't just philosophical musings. They arise from some of the most intriguing scientific theories. For example, quantum mechanics suggests that every quantum event could split reality into multiple outcomes. In one universe, a particle moves left, in another it moves right. If you follow that idea to its logical conclusion, you end up with a vast, perhaps infinite, multiverse, all springing from the fundamental unpredictability of the quantum world. And what about the cosmic scale? Some scientists propose that our universe is just one bubble in a vast cosmic foam, countless universes existing independently, each with its own set of physical laws. Imagine floating in an ocean where every bubble holds a completely different world. So whether it's infinite possibilities, alternate timelines, or entirely separate universes, the interpretations of parallel universes are as diverse as they are mind-bending. But one question remains: if these universes exist, is there any way we can connect with them, or even prove they're real? So, if parallel universes exist, what does that mean for us? It's not just a scientific puzzle, it's a question that shakes the very foundation of how we see ourselves and our place in the cosmos. Let's start with the philosophical implications. If there are infinite versions of reality, then who are you really? Are you just one version of an infinite set of possibilities? It's a deeply unsettling idea. For centuries, philosophers have grappled with questions about identity, free will, and purpose. But the notion of parallel universes takes those questions to a whole new level. Think about it: in one universe, you might make a decision that leads to incredible success. In another, you might fail spectacularly. Does that mean your choices don't matter? Or does it mean every choice matters, because each one creates a new reality? And then there's the question of fate and free will. If parallel universes exist, does that mean every possible version of your life is already out there predetermined? Or are you still in control of your destiny, shaping one path while others unfold elsewhere? It's a paradox that challenges everything we think we know about how the universe works and how we work within it. Now let's shift gears to the scientific implications. The idea of parallel universes isn't just philosophical speculation. It emerges from some of the most cutting-edge theories in physics. For example, the many worlds interpretation of quantum mechanics suggests that every time a quantum event occurs, the universe splits into multiple versions. In one version, the particle moves left, in another it moves right. This isn't just a thought experiment. It's a direct consequence of how quantum systems behave. And on a larger scale, there's the theory of cosmic inflation. According to this idea, our universe may be just one of countless others created during the rapid expansion of space after the Big Bang. Each universe could have its own unique physical laws, making our universe just a tiny speck in an unfathomably vast multiverse. But here's the kicker: if these parallel universes exist, how do we prove it? After all, they lie beyond the reach of our current technology and understanding. Yet, scientists continue to search for clues, subtle hints in the cosmic microwave background, patterns in the distribution of galaxies, or even phenomena we haven't yet discovered. So what does it mean to live in a universe where infinite possibilities exist, but we may never fully grasp them? Are we explorers of a vast unknown, or merely observers of a single, narrow thread? The implications are as profound as they are mysterious, forcing us to rethink not just what we know, but how we know it. Now, let's dig into the science, the hard evidence and the theories that bring the idea of parallel universes out of the realm of imagination and into the world of physics. One of the most fascinating scientific ideas tied to parallel universes comes from quantum mechanics, the branch of physics that deals with the tiniest building blocks of reality, particles like electrons and photons. At this microscopic scale, the universe doesn't behave in ways we're used to. Instead of being predictable, particles exist in a strange state of uncertainty. Here's where it gets really interesting. In 1957, physicist Hugh Everett proposed a radical idea known as the many worlds interpretation. He suggested that whenever a quantum event occurs, whenever a particle has to choose between different states, the universe splits. Each possible outcome happens, but in a different branch of reality. Think of it like this: you're standing at a crossroads, deciding whether to turn left or right. According to the many worlds interpretation, you turn left in one universe, and in another you turn right. Both decisions are real, they just happen in separate realities. This theory isn't just about choices, it's about everything. Every quantum decision creates a branching network of parallel universes, each one following a different path. It's like an endlessly expanding tree, where every split creates new realities. But here's the catch: if these universes exist, we can't interact with them. They're separate, like pages in a book that never overlap. This makes the many worlds interpretation both thrilling and frustrating. It offers a stunning explanation for quantum behavior, but leaves us questioning whether we'll ever know if these other worlds truly exist. Still, the theory has its supporters. Many physicists believe it solves some of the deepest mysteries of quantum mechanics. But it also raises profound questions about reality. If the universe is constantly splitting, then how do we define what's real? And if every possibility exists somewhere, does that mean nothing is truly unique, including you? The many worlds interpretation is just the beginning. To uncover even more about the science of parallel universes, we'll need to go beyond the quantum scale and into the vastness of the cosmos itself. If the many worlds interpretation explores the smallest scales of reality, cosmic inflation takes us to the largest, the very origins of the universe itself. This theory not only explains how our universe came to be, but it might also suggest the existence of countless others. So, what is cosmic inflation? Imagine the universe as we know it, a vast expanse filled with galaxies, stars, and planets. Now, rewind time. About 13.8 billion years ago, everything we see today was packed into an unimaginably small, hot, and dense point. Then, in a fraction of a second, something extraordinary happened. The universe underwent a rapid, almost explosive expansion. This is what scientists call inflation. But here's where it gets fascinating. Many physicists believe that this process didn't just create our universe. Instead, inflation might have been happening everywhere, creating countless bubble-like universes, each expanding and evolving independently. Picture a pot of boiling water with bubbles forming, growing and floating away. Each bubble is its own universe with its own unique physical properties and laws of nature. This means that our universe might be just one bubble in an endless multiverse, a vast cosmic foam where universes are born and die. And here's the truly mind-bending part. In some of these universes, the laws of physics could be completely different. Perhaps gravity is stronger. Maybe stars never form. Or maybe life evolves in ways we can't even imagine. The idea of a multiverse emerging from cosmic inflation isn't just theoretical. Some scientists are actively searching for evidence. For instance, if our universe ever collided with another bubble universe in the distant past, it could leave subtle imprints in the cosmic microwave background, the faint glow of radiation left over from the Big Bang. But even without direct proof, cosmic inflation offers an elegant explanation for why our universe looks the way it does. It might not just be a fluke. Instead, we could be one of countless universes, each with its own story, its own reality. So what does this mean for us? If the multiverse exists, then everything we know, our galaxy, our planet, even ourselves, might be just one tiny piece of an incomprehensibly vast puzzle. And that's both humbling and exhilarating. But the search for evidence continues. Could we ever find direct proof of other universes? Or will they remain forever beyond our reach, hidden in the depths of an infinite multiverse? If parallel universes exist, how would we ever prove it? Scientists are exploring some of the most ancient clues in the cosmos, remnants from the early universe itself, to find answers. These observations might hold the key to unlocking the mystery of the multiverse. Let's start with the cosmic microwave background, or CMB. This faint glow of radiation is like a time capsule, a snapshot of the universe just 380,000 years after the Big Bang. It's the oldest light we can observe, and it holds a wealth of information about how our universe began. When scientists study the CMB, they look for patterns, subtle irregularities in this ancient light. These patterns tell us how matter was distributed in the early universe and how galaxies eventually formed. But here's the intriguing part. If our universe ever interacted with another universe, perhaps a neighboring bubble in the multiverse, it could have left a detectable mark in the CMB. Imagine two soap bubbles colliding. The point of contact creates a ripple. Similarly, a collision between universes might have left imprints in the fabric of space-time that we could still see today. So far, no conclusive evidence of such collisions has been found, but that hasn't stopped scientists from looking. Telescopes like the Planck satellite have mapped the CMB in exquisite detail, searching for anomalies that could hint at a multiverse. Another area of exploration comes from the distribution of matter in the universe. If parallel universes exist, they might subtly influence how galaxies are arranged on the largest scales. Some researchers have suggested that strange alignments or patterns in the cosmos could be the result of interactions with other universes. And then there's the concept of quantum fluctuations. These tiny variations in energy, present during the inflationary period, could have seeded the creation of not just galaxies but entire universes. Observing these fluctuations and understanding their role might provide further clues about the multiverse. But here's the challenge: proving the existence of other universes is incredibly difficult. By definition, these universes exist outside our own, beyond the boundaries of what we can directly observe. It's like trying to see the other side of a wall when you're locked in a room. Still, the search continues. Scientists are pushing the limits of technology and theory, probing deeper into the origins of our universe. Every discovery brings us closer to understanding whether we're part of a multiverse, or whether our universe stands alone in the vast expanse of reality. So, could the answers be hidden in the light from the earliest moments of creation? Or will the multiverse remain forever a tantalizing mystery, just out of reach? Now, let's step away from the theories for a moment and dive into something more imaginative. What would it actually be like to live in a parallel universe? Could it feel similar to our own reality, or would it be so different that we wouldn't even recognize it as life? Picture this: you wake up one morning in a parallel universe. At first glance, everything looks the same. The sky is blue, the trees sway in the wind, and the familiar buzz of life fills the air. But as you step outside, small details start to shift. Maybe the cars hover instead of drive. Perhaps the laws of physics allow people to float rather than walk. Or maybe history unfolded differently. Your city, your country, even your own life took a drastically different path. Now imagine another version, one where the differences are subtle. Maybe you're living the same life, but with a few twists. You took a different career, married someone else, or pursued a long-forgotten dream. In a parallel universe, every decision, every chance encounter could lead to an entirely new reality. But what if the differences were more profound? In some universes, the laws of nature themselves could be entirely alien. Stars might never form, planets might not exist, time could flow backward, or gravity could be so weak that nothing holds together. Would such a universe even feel like reality to us? Here's a mind-bending thought. If we were to somehow find ourselves in a parallel universe, would we even know? Our senses and brains are adapted to perceive the reality we live in. A universe with radically different laws of nature might be completely incomprehensible, like trying to imagine a color you've never seen. But the biggest question is perhaps this: in a world of infinite possibilities, how much would those differences actually matter? Would you still be you in another universe? Or would the subtle changes in your environment, your choices, and your circumstances create someone entirely new? Exploring what it's like to live in a parallel universe forces us to reflect on what defines reality and what defines us. Is it our surroundings, our experiences, or something deeper that transcends all possible worlds? And yet, there's one more tantalizing question. If these universes are out there, could we ever visit them? Could we cross the boundaries of our reality and step into another? That's what we'll explore next. Now comes the big question, the one that feels like it's straight out of science fiction. Could we ever travel to other realities? Could we leave our universe and step into a parallel one? To answer that, we need to start by understanding the boundaries of our own universe. Right now, everything we know about space, time, and matter suggests that our universe is a closed system. Like living inside a snow globe, we're confined to the dimensions and physical laws that define our reality. So the idea of breaking out and entering another universe seems impossible. But impossible is a word that science loves to challenge. Some theories suggest there might be loopholes in the fabric of space-time, portals, if you will, that could allow travel between universes. Think of wormholes, those hypothetical tunnels connecting distant parts of space. Some scientists believe that if wormholes exist, they might also act as bridges between entirely different realities. Here's the catch: wormholes, if they exist at all, would be incredibly unstable. The tiniest disturbance could cause them to collapse before anyone or anything could pass through. But what if we could stabilize one? Theoretically, advanced civilizations, far more advanced than ours, might have the technology to harness wormholes as gateways to other universes. And then there's the idea of quantum entanglement, a strange phenomenon where two particles, no matter how far apart, are mysteriously connected. Some physicists speculate that this spooky action at a distance might hint at deeper connections between universes. Could quantum mechanics provide a roadmap for traveling between realities? Of course, there are massive challenges. Even if we discovered a way to reach another universe, we'd have no idea what conditions await us. Would it be safe? Would the laws of physics there even allow us to survive? Imagine stepping into a universe where gravity is so strong that you're instantly crushed, or so weak that atoms can't hold together. But there's another question, perhaps a more philosophical one. If we could travel to other realities, should we? What happens if we encounter another version of ourselves? What ethical dilemmas arise from meddling in a universe that isn't ours? For now, the idea of traveling to parallel universes remains a tantalizing dream, a frontier for future scientists and explorers to imagine. But even if we can't cross the boundaries of our reality, the very act of asking these questions pushes the limits of our understanding and inspires us to think beyond what we know. So, will we ever build a bridge to another universe? Or will the multiverse remain forever out of reach, a world of infinite possibilities just beyond the edge of our imagination? Now, let's confront one of the most profound questions about parallel universes. What happens if we interact with another version of ourselves? It's an idea that feels exciting and unsettling all at once, raising ethical and philosophical dilemmas that challenge how we see ourselves and our place in reality. Imagine meeting another you. At first, it might feel like looking into a mirror, but this reflection isn't exact. Maybe they made different choices. Maybe they're living the life you always dreamed of, or the one you feared. How would that change the way you see yourself? Would you envy them? Pity them? Or would you feel a sense of connection, knowing that their life could so easily have been yours? Here's the ethical dilemma. Would you have the right to influence their reality? If their life is better, would you try to learn from them or even take their place? If it's worse, would you feel obligated to help them, even if it meant disrupting their world? And what about the consequences of your interaction? Think about the ripple effect. In your universe, every choice you make affects the people around you. But in a parallel universe, the stakes could be even higher. A small action, one conversation, one decision, might radically alter an entire timeline. Then there's the question of identity. If there are infinite versions of you, is there such a thing as the real you? Are you defined by your choices, your circumstances, or something deeper, something constant across all realities? This isn't just a philosophical exercise, it's a question that strikes at the core of how we understand ourselves. And finally, the most unsettling question of all, what if the other version of you is fundamentally different? What if they've made choices that you can't reconcile with, choices that challenge your sense of morality or identity? Could you still see them as you, or would they feel like a stranger? Interacting with another version of ourselves isn't just a fascinating what if. It forces us to confront the nature of free will, morality, and selfhood. It's a thought experiment that asks, if we are one of infinite possibilities, how much of who we are is truly unique? Perhaps the ultimate ethical question is this: if we ever had the chance to step into another version of our life, would we take it? Or would the risks to ourselves, to others, and to reality itself be too great? The idea of parallel universes isn't just a scientific or philosophical concept. It's a profound challenge to how we perceive reality and our place within it. For centuries, humanity has sought to understand the cosmos, from ancient myths about the heavens to the modern equations of physics. We've long assumed that our universe is all there is, that everything we know and experience exists within this singular reality. But the possibility of parallel universes forces us to confront an unsettling truth. What if we're just a tiny piece of something infinitely larger? Think about it. If there are countless other universes, each with its own stars, galaxies, and perhaps even life, then our universe, our home, might not be as unique as we once thought. That realization can feel humbling, even disorienting. Are we just one story among billions, playing out in an endless cosmic library? And what about you? If infinite versions of you exist, each shaped by slightly different choices or circumstances, then what defines your individuality? Are you truly unique, or just one expression of endless possibilities? This idea doesn't just challenge how we see ourselves, it also forces us to rethink humanity's place in the grand scheme of things. For generations, we've seen ourselves as the center of the story, the observers of the universe. But if the multiverse exists, then we're not the center at all. We're a single thread in a vast, intricate tapestry, woven alongside infinite others. But here's the paradox. While the concept of parallel universes can make us feel small, it can also inspire a profound sense of connection. If reality is infinite, then every choice, every possibility, every moment has value. It's a reminder that, even in the vastness of the cosmos, our actions still matter, because they're part of something much greater than ourselves. The idea of parallel universes isn't just about what's out there, it's about how we understand our place in it. Are we explorers, seeking answers to the ultimate mysteries? Or are we simply participants in a story so vast and complex that we may never fully comprehend it? Either way, it's a journey that forces us to see reality and ourselves in a whole new light. The concept of parallel universes doesn't just expand our view of the cosmos. It directly challenges some of our most deeply held beliefs about free will, fate, and the nature of consciousness. Let's start with free will. We like to think of our choices as defining who we are. Every decision, big or small, feels like a unique thread in the fabric of our lives. But what if, in the multiverse, every choice you could possibly make does happen? In one universe you chose one path, in another a completely different one. If every possibility is realized somewhere, then do you truly have free will? Or are you just playing out one version of an endless set of possibilities? Then there's fate. If parallel universes exist, does that mean everything is inevitable? If every outcome exists in some reality, then does it matter which choices you make? Or does the existence of infinite possibilities mean that no single outcome is destined? It's a paradox that forces us to rethink what it means to be in control of our lives, and whether the idea of control itself even makes sense in a multiverse. And what about consciousness? Who are you in the context of infinite versions of yourself? Is your consciousness unique to this universe, or is it somehow connected to all your counterparts in other realities? Philosophers and scientists have long debated whether consciousness is a purely physical phenomenon or something more profound. The multiverse takes this debate to a new level. Could our minds, our very sense of self, be just one fragment of a larger, interconnected whole? Here's a thought experiment. If you could observe every version of yourself across all universes, would you still feel like the same person? Or would the differences, subtle or dramatic, redefine your understanding of who you are? The idea of parallel universes doesn't just stretch the boundaries of science, it forces us to confront some of the most profound questions about existence itself. It challenges the very concepts of individuality, choice, and identity, leaving us to wonder, in a reality of infinite possibilities, what does it truly mean to be? These are not easy questions to answer, but they remind us that exploring the multiverse isn't just a journey through space and time, it's a journey into the depths of our own understanding, one that may forever change the way we see ourselves and the universe around us. Parallel universes don't just challenge our understanding of reality, they open the door to entirely new realms of discovery. If even a fraction of the multiverse theories prove true, they could revolutionize the way we see the cosmos and our place within it. Imagine the possibilities. If we could uncover evidence of other universes, we might learn why our universe has the specific properties it does, why the laws of physics are fine-tuned to allow stars to form, planets to exist, and life to evolve. Perhaps, in studying other realities, we'd find universes where the conditions are wildly different, teaching us more about the delicate balance that makes our own universe so special. And what about the origins of reality itself? Parallel universes could provide clues about how and why the universe began. Some scientists propose that studying the multiverse might reveal whether the Big Bang was a singular event or just one of countless beginnings in an endless cycle of cosmic creation. Then there's the technological potential. If we could somehow harness the principles of parallel universes, like the mysterious connections hinted at by quantum mechanics, imagine what might be possible. Could we use those principles to solve problems we've never been able to solve before, like faster-than-light travel, infinite energy sources, or even new ways to explore the cosmos? But perhaps the greatest discoveries would come not from the differences between universes, but from what they share. By studying the multiverse, we might uncover universal truths, patterns or principles that apply across every reality. These insights could help us better understand the deepest questions about existence, why there is something rather than nothing, what consciousness truly is, and what the ultimate fate of reality might be. Of course, these discoveries are still far off, lying on the very edges of what we can imagine. But the potential is breathtaking. The multiverse, if real, doesn't just expand the cosmos, it expands the boundaries of human knowledge, inviting us to explore not just the universe we live in, but the infinite possibilities that lie beyond. Ultimately, the pursuit of understanding parallel universes isn't just about science, it's about curiosity. It's about the human drive to seek answers to the biggest questions, to push past the limits of what we know, and to embrace the unknown with open minds and boundless wonder. The discoveries we make might not just change what we know about the universe, they might change what we know about ourselves. The possibility of parallel universes is more than just a scientific theory or a philosophical idea, it's an invitation to expand our imagination and challenge the way we see reality. Few concepts are as captivating or thought-provoking, drawing us into questions that seem to stretch beyond the limits of what we can understand. If these universes exist, they offer a glimpse into infinite possibilities, worlds where history unfolded differently, where the laws of physics may not resemble our own, or where versions of ourselves are living lives we can only dream of. But even if parallel universes remain forever out of reach, the very act of exploring them forces us to think bigger, to ask questions that transcend the boundaries of science and philosophy. At its core, the idea of parallel universes reminds us of the vastness of reality. It's humbling to imagine that our universe might be just one small piece of an endless multiverse, and yet it's exhilarating to know that we're part of something so immense, so mysterious and so beautiful. And perhaps, whether or not we ever find proof of other realities, the most important discovery might be what this exploration teaches us about ourselves, about our place in the cosmos, about the choices we make, and about the boundless curiosity that drives us to keep asking, keep searching, and keep wondering. So, as we close this journey, consider this. In a universe so full of mystery, where every possibility could exist somewhere, what does that mean for the choices you make today? What does it mean for how you see yourself, your world, and the infinite unknown? The answers may lie beyond our reach, but the questions will always push us forward. So, as you step back into your own universe, carry this thought with you. Every question we ask, every possibility we imagine, brings us closer to understanding the extraordinary reality we call home. And who knows? Perhaps, somewhere in another reality, another version of you is asking these very same questions, dreaming, exploring, and seeking answers in their own way. Everything we know represents just 5% of the universe. What is the rest? Normal matter protons, neutrons, and electrons make up just 5% of the universe. Staggeringly, the other 95% is something which we cannot fathom, see or understand. We call it dark matter, which makes up 27% of the universe, and dark energy, which makes up 68%. But what are these mysterious components of our universe? Dark matter and dark energy are two mysterious concepts in astrophysics that scientists use to explain some of the strange observations that we make about the universe. Dark matter is a type of matter that does not interact with light or any other form of electromagnetic radiation. This means that we cannot directly detect it using telescopes or other instruments that rely on light. However, scientists can infer its existence by observing its gravitational effects on visible matter, such as stars and galaxies. Dark matter is thought to make up about 85% of the total matter in the universe, but we still do not know what it is made of. It does not behave like any of the known particles that make up ordinary matter, such as protons and electrons. Some theories propose that dark matter consists of undiscovered particles that do not interact with light or other forms of radiation, while others suggest that it may be made up of exotic objects such as black holes. Dark energy, on the other hand, is a hypothetical form of energy that is thought to permeate all of space and is responsible for the accelerating expansion of the universe. Unlike dark matter, which has a gravitational effect that slows down the expansion of the universe, dark energy has a repulsive effect that causes the expansion to speed up. The exact nature of dark energy is not well understood, but it is thought to be a property of space itself, rather than a type of matter or energy that we can directly observe. Scientists believe that dark energy makes up about 68% of the total energy in the universe. How many dimensions does the universe have? To the best of our knowledge, the universe as we know it has 3 spatial dimensions: length, width, and height, and 1 dimension of time, making a total of 4 dimensions in spacetime. This is known as the 4-dimensional spacetime. However, some theories in physics, such as string theory, propose that there may be more than 4 dimensions, possibly up to 11 dimensions. But these extra dimensions are thought to be curled up or compactified to be too small to be observed at our scale. This means that although they may exist, they are not directly observable, and their effects on the 4-dimensional spacetime can only be inferred through their influence on the physical phenomena that we can observe. These additional dimensions would help us unify the mathematical basis of the 4 fundamental forces of nature: the strong nuclear force, the weak nuclear force, the electromagnetic force, and gravity. Do these higher dimensions exist? And if they do, is there a way for us to measure their presence? Or will we forever be trapped in our 4-dimensional world? What if our universe is just one of a multitude out there? The idea that our universe is just one of many universes, known as the multiverse theory, is a popular concept in modern cosmology and physics. According to this theory, there may be many other universes existing alongside our own, each with its own unique properties and laws of physics. If this is the case, it would have profound implications for our understanding of the universe and our place in it. For example, it could help explain why our universe appears to be finely tuned to support life, known as the anthropic principle. If there are countless other universes with different physical laws and properties, it would increase the chances of at least one of them being able to support life. The multiverse theory also raises questions about the nature of reality and how we define what is real. If there are many different universes with different physical laws, are they all equally real? Or is our universe the only real one? What is time? Time is one of the most difficult properties of our universe to understand. Researchers say that time is a measurable period, a continuum that lacks spatial dimensions. There seems to be an obvious direction of time, and it seems we can't travel backwards in time. Why is this? Are we trapped in the arrow of time, perpetually moving forwards? Is the passing of time intertwined with the way our universe works? According to the theory of Big Bang, time itself began together with the rest of the universe about 13.8 billion years ago. Does that mean that it makes no sense to ask what was there before? Time is a fundamental concept in physics and is often defined as the progression of events from the past, through the present, and into the future. It is a fundamental dimension in which events occur and is often represented as a continuous line or axis. In the context of physics, time is typically measured in units such as seconds, minutes, hours, and years. It is also an essential component of the spacetime continuum, which is the 4-dimensional fabric of the universe, consisting of 3 spatial dimensions and 1 temporal dimension. The flow of time is often described as being unidirectional, meaning that it moves forward and cannot be reversed. This is known as the arrow of time and is often associated with the second law of thermodynamics, which states that entropy, the measure of disorder or randomness, in a closed system tends to increase over time. the nature of time is still a topic of ongoing research and debate in physics and philosophy. Some theories propose that time is an emergent property that arises from the complex interactions of the universe's fundamental components, while others suggest that time is a fundamental property of the universe, akin to space and matter. Particles violating the laws of nature. In certain situations, two particles can seemingly be in instant connection with each other, even if they are located at opposite ends of the universe. The phenomenon is known as quantum entanglement, where two particles can become correlated in such a way that the state of one particle is instantly correlated with the state of the other, regardless of the distance between them. While this may seem like a violation of the laws of nature, it is actually consistent with the principles of quantum mechanics. However, it is important to note that this does not allow for faster-than-light communication or the violation of causality. This is because while the state of the entangled particles may be instantaneously correlated, there is no way to control or manipulate this correlation to transmit information faster than the speed of light. In fact, there is a fundamental principle in quantum mechanics known as the no-communication theorem, which states that it is impossible to use entanglement to transmit information faster than the speed of light. So while quantum entanglement may seem like a strange and mysterious phenomenon, it does not allow for the violation of the laws of nature or the principles of causality. Could this feature of quantum mechanics one day allow us to send information instantaneously over large distances? Are we alone in the universe? There are at least 2 trillion galaxies in the observable universe with more stars and planets in them than all the grains of sand on planet Earth. So, where is everyone? Why haven't we encountered life from elsewhere? Is life incredibly rare? Or does it have a limited lifetime, destroying itself before it has had the chance to seek out other life forms? What does this tell us about the future of humankind? The question of whether or not we are alone in the universe is one of the most intriguing and profound questions we can ask. Given the vast size and age of the universe, it seems unlikely that Earth is the only planet with the conditions necessary for life to emerge. There are likely billions of potentially habitable planets in our galaxy alone. However, the fact that we have not yet encountered any definitive evidence of extraterrestrial life is known as the Fermi paradox. There are many potential explanations for the Fermi paradox, including the possibility that life is indeed rare, that it is difficult for life to evolve beyond a certain point, or that intelligent civilizations have a limited lifespan and self-destruct before they can explore the galaxy. It is also possible that we simply have not looked in the right places yet. Our current methods of searching for extraterrestrial life are still relatively limited, and it is possible that more advanced techniques in the future could uncover evidence of life elsewhere in the universe. Does the self-reference problem distort our perception of the universe? We humans are also part of the universe we inhabit, so when we look out to study the stars and galaxies, are we really neutral observers of the universe? When we explore the universe, we are both observers and the subject of observation. How can we pretend to be neutral when we are deeply embedded in what we explore? Could it be that this self-reference problem affects the way we look at the universe and gives us an overwhelmingly wrong impression? The self-reference problem is indeed a complex issue when it comes to our study and perception of the universe. We are not neutral observers of the universe, but rather we are embedded within it. This self-reference problem can lead to potential distortions in our perception of the universe, as we may unwittingly project our own preconceptions and assumptions onto our observations. For example, we may tend to focus on phenomena that we find particularly interesting or relevant to our own existence, rather than taking a more objective and comprehensive approach. By acknowledging our own biases and limitations, we can work to develop more rigorous and objective methods of observation and analysis. Why is the universe seemingly so perfect for us? The universe seems to be perfectly made for us, but why is this? Why do the fundamental constants of our universe, such as the speed of light, have the values that they do, allowing life to exist? Could it be that there are infinite universes with infinite possibilities, and we merely happen to live in one that is perfect for life? There are a few possible explanations for this apparent fine-tuning of the universe. One possibility is the anthropic principle, which states that the universe is the way it is, because it must be compatible with the existence of observers. In other words, the universe appears fine-tuned for us, because if it were not, we would not be here to observe it. This is sometimes referred to as the selection effect. Why is it easier to destroy something than to put it back together? Entropy is the amount of disorder, chaos, or randomness in a system. One can never reduce entropy. Everything in the universe slowly moves towards disorder. It's very easy to smash a window, but impossible to put it back together exactly as it was before. The principle of entropy moves the universe from structure to chaos, from an ordered state to disorder. What does this tell us about the fate of the universe? As the universe continues to expand, it will eventually reach a state of maximum entropy, where all matter is uniformly distributed and there is no energy gradient available to drive further processes. This state is known as the heat death of the universe, where the universe will be cold, dark, and lifeless. The universe is not a closed system, as it receives energy from stars and other sources, but the overall trend is towards increasing disorder and chaos. However, it is important to note that this process will occur over an extremely long time scale, likely trillions of years in the future. Can anything escape a black hole? We have observed the effects of black holes, and we have seen one directly. The gravitational force of these massive objects pulls everything towards them, even light itself. What happens in the mysterious, infinitely dense center of a black hole? Could there exist such things as white holes, the opposites of black holes, that spew matter and time into our universe? According to our current understanding of physics, nothing can escape a black hole once it has passed the event horizon, which is the point of no return. The gravitational pull of a black hole is so strong that it warps space and time, and anything that crosses the event horizon is inevitably pulled towards the singularity at the center of the black hole, where the laws of physics as we know them break down. We do not know what happens at the center of a black hole, as our current understanding of physics is unable to describe the conditions there. It is commonly believed that the matter at the singularity is infinitely dense and compressed to a point of zero volume, known as a singularity. As for the possibility of white holes, which are hypothetical objects that are the opposite of black holes, there is currently no direct evidence to suggest that they exist. White holes are hypothetical objects that are believed to exist at the other end of a hypothetical wormhole, which is a hypothetical tunnel-like connection between 2 points in spacetime. However, there is no direct evidence to suggest that wormholes exist either. Have you ever looked up at the night sky and wondered about the secrets it holds deep within its starlit expanse? What mysteries lie beyond the reaches of our sight, waiting to be discovered? Welcome to Unlocking the Universe. 10 mind-blowing cosmic mysteries. In today's journey, we're diving into some of the most astonishing and perplexing facts about the cosmos. From the mind-bending reality of black holes to the enigmatic forces of dark matter and dark energy, the universe is far more mysterious and incredible than we could have ever imagined. So buckle up as we explore these cosmic wonders and unravel the mysteries of the universe one fact at a time. Fact 1. The size of the observable universe. Imagine trying to comprehend the full scope of where we are. It's a challenge that stretches the limits of our minds. The observable universe, the part of the cosmos we can theoretically see from Earth, spans about 93 billion light-years in diameter. But what does that really mean? A light-year is the distance light travels in 1 year, nearly 6 trillion miles. Now, multiply that by 93 billion, and you're just starting to scratch the surface of the sheer scale of our universe. Within this unimaginable expanse, there are at least 2 trillion galaxies, each brimming with millions to trillions of stars, and even more planets. Each light year, each galaxy, represents a part of the universe full of mysteries yet to be explored. And as vast as the observable universe is, what lies beyond is even more intriguing. Because of the finite speed of light, and the age of the universe we can only see as far as light has had time to travel since the Big Bang. What exists beyond this cosmic horizon remains one of the greatest questions in astronomy. Fact 2. Black holes. These are some of the most mysterious and powerful entities in the universe. A black hole is a point in space where gravity pulls so much that even light cannot get out. The gravity is so strong because matter has been squeezed into a tiny space. Most black holes form from the remnants of a large star that dies in a supernova explosion. When the star's core collapses under the weight of its own gravity, it can compress to a point creating a black hole. In 2019, humanity got its first ever look at a black hole's event horizon, thanks to the Event Horizon Telescope. This image captured a black hole at the center of the galaxy M87, revealing the shadow of the black hole surrounded by a bright glowing ring of light. Bending hole is so strong that it distorts space and time around it. If you were to approach a black hole, you would experience something known as spaghettification, where you'd be stretched into a thin strand of matter due to the gravitational forces. Our very own Milky Way galaxy harbors a supermassive black hole at its center, known as Sagittarius A. Supermassive black holes like this one might play a key role in how galaxies form and evolve over billions of years. Fact 3. Dark matter and dark energy. Though we can see stars, planets, galaxies, and even the light from distant cosmic events, these account for only about 5% of the universe. The rest is made up of dark matter and dark energy, which together compose about 95% of the total mass and energy of the cosmos. Dark matter, making up about 27% of the universe, does not emit, absorb, or reflect light. It neither glows nor can be directly observed, yet we know it exists because of the gravitational effects it has on the visible matter around it. This mysterious substance binds galaxies together and is essential for the structure of the universe. The remaining 68% is dark energy, an even more mysterious force that is driving the accelerated expansion of the universe. Unlike anything else we know, dark energy appears to be a property of space itself. Since the Big Bang, the universe has been expanding, but thanks to dark energy, this expansion is not slowing down as previously thought, it's speeding up. This discovery in the late 1990s has transformed our understanding of the cosmos and its future. The enigmatic nature of dark energy poses one of the biggest questions in science. What is its true nature, and what does it mean for the fate of the universe? Will the universe continue to expand indefinitely, tear itself apart, or eventually stop expanding? Fact 4. The multiverse theory. While our universe is vast beyond comprehension, it might not be the only one. According to the multiverse theory, what we have traditionally called the universe could be just one of countless others in a grander multiverse. This theory extends from ideas in physics that suggest possible multiple universes may arise from the same quantum fluctuations that inflated our own universe. These universes might vary dramatically in their laws of physics, their configurations of matter, and even their fundamental constants. One intriguing version of the multiverse is the many worlds interpretation of quantum mechanics, where every decision creates a new split in reality, leading to new universes for each possibility. Imagine a universe where dinosaurs never went extinct, or where gravity is not a fundamental force. Theoretical frameworks like string theory and cosmic inflation provide some support for the multiverse concept, suggesting that the cosmos might consist of multiple dimensions beyond our familiar three-dimensional space. Each of these dimensions could potentially be a separate universe. The idea of a multiverse pushes the boundaries of our understanding and challenges the very notion of reality. It raises profound questions. If other universes exist, could we ever detect them? And what would this mean for our understanding of existence itself? Fact 5. Neutron stars. Among the universe's most extreme objects, neutron stars are the dense remnants of massive stars that exploded in supernovae. Despite their small size, typically about 20 kilometers in diameter, these stars pack a staggering amount of mass. Imagine the mass of the Sun over 1 million times the mass of the Earth. compressed into a sphere just 12 miles across. The result is a material so dense that a single teaspoon of neutron star matter would weigh about 6 billion tons. That's equivalent to the combined weight of all humans on Earth. Neutron stars are fascinating not only because of their density, but also their rapid rotation and strong magnetic fields. Some neutron stars spin hundreds of times per second. These stars can also appear as pulsars, which are neutron stars that emit beams of electromagnetic radiation. These beams are only visible when they sweep across the Earth, similar to the light from a lighthouse. Pulsars are so precise in their rotation that astronomers use them as cosmic clocks. Some neutron stars are known as magnetars, which have the most powerful magnetic fields in the universe. These fields are so intense that they can cause starquakes and emit giant flares of energy, which can disrupt satellites and create spectacular light shows in the sky. Fact 6. The expanding universe. Since the dawn of the 20th century, astronomers have understood that the universe is expanding. This was first proposed by Belgian priest and astronomer Georges Lemaitre, and later confirmed by Edwin Hubble, who observed that distant galaxies are moving away from us in every direction. What's fascinating is that it's not just the galaxies moving through space. The fabric of space itself is expanding. This means that, with each passing second, every part of the universe is getting slightly further away from every other part. Scientists measure this expansion using something called redshift. As light from distant galaxies reaches us, it shifts to longer, redder wavelengths as space expands. This shift provides crucial information about the speed of the galaxy's recession due to the universe's expansion. These 6 cubes show the simulated distribution of galaxies at redshifts 9, 7, 5, 3, 2, and 1, with the corresponding cosmic ages shown. As the universe expands, the density of galaxies within each cube decreases, from more than 500,000 at top, left to about 80 at lower right. Each cube is about 100 million light-years across. Galaxies assembled along vast strands of gas separated by large voids, a foam-like structure echoed in the present-day universe on large cosmic scales. This visualization shows the number and clustering of simulated galaxies at different cosmic ages, ranging from 4% to 43% of the universe's current age of 13.8 billion years. Each cube represents a fixed volume of space about 100 million light-years per side. Over the sequence, the expansion of the universe quickly lowers the density of galaxies. Each cube shows a specific cosmological redshift, from 9 to 1, with earlier cubes cast in redder shades. Recent discoveries have revealed that the universe is not just expanding, but it's accelerating. This acceleration is thought to be driven by dark energy, an unknown form of energy that makes up about 68% of the universe. The implications of this expanding universe are profound. If the expansion continues indefinitely, the future of the cosmos could be a big freeze, where galaxies eventually drift so far apart that the stars burn out, leaving a cold, dark universe. Fact 7. The cosmic microwave background. Discovered quite by accident in 1964, the cosmic microwave background, or CMB, is a faint glow of light that fills the entire universe. It is the afterglow, radiation, left over from the Big Bang, and it provides us with a snapshot of the infant universe just 380,000 years after its inception. This cosmic relic was stumbled upon by Arno Penzias and Robert Wilson, who initially mistook it for noise from pigeons in their antenna. Their discovery provided strong evidence for the Big Bang theory, fundamentally altering our understanding of the universe's origins. The CMB is not perfectly uniform. It contains tiny temperature fluctuations that represent the seeds of all future structure, the galaxies, clusters, and vast voids that would eventually form. By studying these patterns, cosmologists can learn about the composition and evolution of the universe. At the time the CMB was emitted, the universe had cooled enough for electrons and protons to combine into neutral atoms, making the universe transparent to radiation for the first time. This moment is known as recombination. Today, advanced satellites and observatories continue to study the CMB to glean more insights into the universe's rate of expansion, the nature of dark energy, and even hints about inflation, a theorized exponential expansion of the early universe that would have happened a fraction of a second after the Big Bang. Fact 8. Life's ingredients are cosmic. It's a humbling and fascinating fact that nearly all elements on Earth were formed in the heart of stars. This cosmic alchemy, where simple elements like hydrogen and helium are transformed into heavier elements, occurs under the extreme pressures and temperatures found in stars. Throughout their lifetime, stars fuse hydrogen into helium, helium into carbon, and so on, up to iron. But the creation of elements heavier than iron requires even more dramatic events, such as supernovae and the collision of neutron stars. When a massive star explodes in a supernova, it releases an immense amount of energy and spews newly formed elements into space. Even gold, platinum, and uranium are forged in these cosmic catastrophes and the cataclysmic mergers of neutron stars. These elements, scattered across the cosmos, eventually coalesce into new star systems and planets, including our own. The carbon in our bodies, the oxygen we breathe, and the calcium in our bones all originated from stardust. So next time you look up at the night sky, remember that we are not just inhabitants of the universe, we are literally made of the universe. Every atom in your body was once part of a star far across the galaxy. We are, in the most literal sense, stardust. Fact 9. Exoplanets and the search for life. Since the confirmation of the first exoplanets in the 1990s, our understanding of the universe has expanded dramatically. To date, thousands of planets have been discovered orbiting stars outside our solar system. These exoplanets come in a fascinating array of sizes, compositions, and orbits. Among these, some are eerily similar to Earth, with conditions that may support life. Scientists use advanced telescopes like Kepler and test to detect these distant worlds by watching for the slight dimming of a star as a planet passes in front of it, a method known as the transit method. Particularly exciting are those exoplanets in the habitable zone, a region around a star where conditions might be right for liquid water, a crucial ingredient for life, as we know it to exist on the surface. The quest to find extraterrestrial life is intensifying. Future missions plan to analyze the atmospheres of these exoplanets, searching for signs of life such as oxygen, ozone, and methane. Such discoveries could answer one of humanity's oldest questions: are we alone in the universe? Every new exoplanet discovered broadens our perspective, reminding us of the vast possibilities that lie beyond our home planet. As we continue to explore, we not only learn more about the universe, but also about the potential for life's diversity beyond Earth. Fact 10. The youngest galaxies. By peering deep into the cosmos, astronomers are not just looking out in space, they are also looking back in time. Using powerful telescopes like the Hubble Space Telescope and the upcoming James Webb Space Telescope, scientists have been able to observe galaxies as they existed just a few 100 million years after the Big Bang. These observations are crucial because they show us the earliest stages of galaxy formation. The youngest galaxies are often small, irregular, and highly active, quite different from the large, well-structured spiral and elliptical galaxies we see in the nearby universe. Studying these young galaxies helps us understand how galaxies grow and evolve. For instance, we see that early galaxies were often much more chaotic, with high rates of star formation and frequent collisions that eventually led to the large, organized structures of stars we are familiar with today. These galactic youths are not just random patches of stars, they are the building blocks of today's universe. Observing them offers clues about the fundamental processes that have shaped everything we see around us, from the distribution of galaxies to the very structure of the cosmos. As technology advances, we will continue to push the boundaries of what we can observe. Each new discovery not only helps us piece together the cosmic puzzle, but also connects us more deeply with the origins of our own galaxy and ultimately, our place in the universe. Thank you for joining me on this cosmic voyage. The universe is not just something out there, it's a part of us, and we continue to explore it. We learn more about ourselves. If you enjoyed this exploration, share your thoughts and questions in the comments below. What part of the universe fascinates you the most? Let's keep the conversation going. Don't forget to like, subscribe, and click the bell icon to receive updates on our latest videos. Together, let's continue to unlock the mysteries of the universe. Imagine this: a butterfly flaps its wings in the dense Amazon rainforest. Its delicate motion stirs the air, setting off a chain of events that eventually leads to a storm forming on the other side of the world. This might sound like poetry or fantasy, but it touches upon something deeply profound, a question that has captivated scientists, philosophers, and spiritual thinkers for centuries. Could every action, no matter how small, truly ripple outward in ways we can scarcely imagine? Could the universe itself be a vast, interconnected web where everything is bound together by invisible threads? In our day-to-day lives, it's easy to see ourselves as isolated beings, each pursuing our own path, each grappling with our own concerns. Yet, beneath the surface, the world reveals a different story, one of profound interconnection. Every thought, every choice, every particle of matter seems to be part of a larger whole. To explore this idea is to venture into the heart of existence itself, to ask what it truly means to be a part of this vast, mysterious system we call reality. Why does this matter? In a world that feels increasingly fragmented, where global crises collide with individual struggles, understanding the threads that bind us can reshape how we see ourselves and each other. It challenges us to think beyond borders, beyond personal interests, and even beyond the limitations of our senses. Whether through the lens of science, philosophy, or our daily lives, the idea of interconnection offers not only insights into the workings of the universe, but also guidance on how to live within it. Let's begin with an experiment of imagination. Picture a spider's web stretching endlessly in all directions. At each intersection lies a shimmering drop of dew, reflecting every other droplet on the web. A single vibration, no matter how faint, ripples through the entire structure. Now, replace the silk threads with atoms, ecosystems, and human relationships. This is not just an image, but a metaphor for the reality we inhabit, a world where every movement, no matter how small, resonates across the whole. As we delve deeper into this idea, we'll journey through the realms of cutting-edge science, uncover the echoes of ancient wisdom, and draw connections to the choices we make every day. Along the way, we'll confront questions that defy simple answers. How does the universe remain so interconnected despite its vastness? Can the actions of a single individual ripple outward to shape the destiny of others, or even the planet? And if all things are truly connected, what responsibilities do we bear as part of this intricate web? This journey is not just about understanding the world, it's about finding our place within it. So, let's explore this profound question together. What does it mean to live in a universe where everything is connected? Let us dive into the science of interconnection, where the universe reveals its most intriguing secrets. At the heart of modern physics lies a phenomenon so strange that even Einstein himself called it spooky action at a distance. Quantum entanglement, this mysterious connection between particles, has challenged the way we understand reality. When two particles become entangled, their states are linked in such a way that a change in one instantly affects the other, regardless of the distance between them. Imagine this: two twins, separated by galaxies, yet if one raises a hand, the other does the same at the exact moment. This isn't a thought experiment, it's a proven reality. Scientists have measured entangled particles separated by over 1,200 kilometers, showing that their connection defies the classical boundaries of time and space. What does this mean for us? It suggests that the universe may not be as fragmented as it appears. Instead, it hints at a deeper, unified reality, one where everything may be fundamentally connected. If, as some physicists propose, all particles in the universe were entangled at the moment of the Big Bang, it's not entirely unreasonable to wonder, are we still connected to the stars, the planets, and each other? But interconnection isn't confined to the quantum realm. Nature itself demonstrates this principle on a grander scale. Consider a meadow alive with buzzing bees and blooming flowers. This idyllic scene is underpinned by a complex web of interdependence. Bees pollinate plants, enabling them to reproduce. Plants provide food and oxygen for countless organisms. Animals, in turn, spread seeds, ensuring the survival of future generations. Disrupt any part of this system, and the consequences ripple outward. If the bees vanish, crops fail. If the forests fall, the climate changes. These connections are not abstract, they are the very fabric of life on Earth. And yet, the connections go deeper still. In the 1960s, meteorologist Edward Lorenz discovered what he called the butterfly effect. A small, seemingly insignificant action, like the flap of a butterfly's wings, can set off a chain of events, leading to vastly different outcomes, like a hurricane forming halfway across the world. This principle, rooted in chaos theory, reveals that even the most unpredictable systems, such as weather or financial markets, are governed by underlying patterns. What begins as a whisper can grow into a roar. This ripple effect isn't limited to science or nature, it extends into our lives and our choices. History is full of moments where small actions led to monumental changes. A single decision, a conversation, or even a chance meeting has the potential to alter the course of history. It's a reminder that what we do matters, even if we cannot always see the full extent of our impact. As we reflect on these scientific revelations, one truth emerges: nothing exists in isolation. From the entangled particles of quantum physics to the ecosystems that sustain life and the patterns of chaos that shape our world, interconnection is not just an idea, it's the reality of the universe. But this understanding is not new. Across centuries and cultures, ancient philosophies and spiritual traditions have explored this same truth in their own profound ways. Let's turn now to the wisdom of the past and discover how it aligns with the discoveries of modern science. Throughout history, the idea of interconnection has been a cornerstone of philosophical and spiritual thought, particularly in the traditions of the East. Hinduism and Buddhism, for example, offer vivid metaphors that echo the interconnectedness we now explore through science. One of the most compelling is the concept of Indra's net, an ancient image describing a vast, cosmic web that stretches infinitely in all directions. At each intersection of this net lies a jewel, and each jewel reflects every other jewel. The implication is profound: every part of the universe is linked, and the whole is reflected in each individual part. This imagery is strikingly similar to modern ideas of holography, where every fragment contains the entirety of the image. It also aligns with quantum physics, where particles, no matter how distant, are fundamentally connected. Such parallels suggest that ancient wisdom may have intuited truths that science is only now beginning to uncover. Buddhism offers another perspective through its principle of dependent origination, which states that nothing exists independently. Everything arises from a network of causes and conditions. Consider a tree. It isn't just a tree, it's sunlight, rain, soil, and time. Remove any one of these and the tree cannot exist. This understanding extends beyond physical objects to encompass human experiences, relationships, and actions. Recognizing this interdependence fosters compassion, as it highlights how our choices inevitably affect others. Similarly, Taoism emphasizes harmony through unity. The Taoist worldview sees the universe as a single, harmonious entity where opposites yin and yang are not in conflict but in balance. To live well, Taoism teaches, is to flow with this interconnected rhythm of life, acting in harmony with the natural order rather than against it. While Eastern traditions embrace unity as a core truth, Western thought has approached interconnection through reason and observation. The 17th century philosopher Baruch Spinoza proposed a radical idea that everything in the universe is part of a single, infinite substance, which he called God or nature. Spinoza argued that distinctions between self and other, or mind and body, are illusions. All things are manifestations of the same underlying reality. This philosophy resonates with modern physics, particularly the idea of a unified field from which all forces and particles arise. More recently, the Gaia hypothesis, developed by James Lovelock, offers a scientific perspective on interconnection. According to this view, Earth functions as a single, self-regulating organism. The planet's atmosphere, oceans, and ecosystems work together to maintain conditions for life. Disruptions in one system, deforestation, pollution, or the loss of biodiversity affect the entire balance. This perspective underscores humanity's responsibility to act as stewards of this interconnected web, recognizing that harming the Earth ultimately harms ourselves. Across cultures, spiritual traditions also echo the idea of humanity's place within a larger cosmic network. Many indigenous beliefs regard nature as sacred and humans as caretakers rather than masters. For example, Native American teachings often emphasize the importance of acting in harmony with the Earth, knowing that every action ripples outward through the web of life. Similarly, Carl Jung's concept of the collective unconscious proposes that humanity shares a reservoir of archetypes, universal symbols, and themes that shape our myths, dreams, and cultures. These shared patterns suggest a psychological connection that transcends individual experience, linking us to one another in profound ways. What emerges from these philosophies, both ancient and modern, is a vision of unity, one that challenges the perception of separateness and celebrates the intricate web of existence. But this understanding isn't limited to abstract thought. It manifests in our daily lives, shaping our relationships, societies, and choices. Let us now turn to the human sphere and examine how interconnection plays out in the world we inhabit every day. In our daily lives, the interconnected web of existence reveals itself most vividly through human relationships and the societies we build. While the threads may seem invisible, they shape every aspect of how we live, think, and act. Take, for instance, the idea of 6 degrees of separation, the theory that every person on Earth is connected to any other by no more than 6 steps. Originating from a social experiment in the 1960s, this concept has since been supported by network science and modern technology. In today's world, social media and global communication have made these connections even more immediate, shrinking the degrees of separation and creating a sense of closeness that transcends physical distance. This interconnectedness isn't just about proximity, it's about influence. Research in social networks shows that emotions, behaviors, and even health can ripple through communities. Happiness, for example, has been found to spread across social circles, with one person's joy increasing the likelihood of happiness in their friends' friends, and beyond. Similarly, negative habits like smoking or overeating can propagate through networks, showing how deeply our actions affect others, often far beyond our direct interactions. Beyond personal relationships, there exists a deeper, collective connection that transcends time and space. Carl Jung's theory of the collective unconscious suggests that humanity shares a repository of universal symbols and archetypes, images, and ideas that appear across cultures, from ancient myths to modern storytelling. These shared patterns hint at a profound psychological connection, where individual minds tap into a collective reservoir of human experience. Consider how the hero's journey, a narrative structure described by Joseph Campbell, appears in myths from every corner of the world, from Homer's Odyssey to Star Wars. Such universality speaks to a shared cultural and spiritual heritage that binds us together. Cultural transmission, or the exchange of ideas and practices, further highlights our interconnection. British scientist Richard Dawkins coined the term meme to describe units of cultural information, traditions, innovations, or even jokes that spread and evolve like genes. Whether it's the global adoption of yoga or the viral spread of social justice movements, these cultural memes demonstrate how ideas traverse borders, connecting humanity in ways that physical presence never could. Yet our interconnectedness extends beyond culture to the very foundations of modern civilization. Globalization has made it abundantly clear that no nation or community exists in isolation. A financial crisis in one country can send shockwaves across the globe, as seen during the 2008 economic downturn. Supply chains, too, illustrate how deeply economies are intertwined, with products often relying on contributions from multiple countries before reaching the consumer. While this interdependence has brought unprecedented prosperity, it also reveals vulnerabilities. Environmental degradation, pandemics, and climate change are stark reminders that global challenges demand collective solutions. This interconnected reality underscores the power of individual and collective actions. Consider the ripple effect of small, positive choices. A single tweet can spark a global movement, as seen with Me Too, where millions shared their stories, reshaping cultural conversations about harassment and power dynamics. Grassroots environmental efforts, such as local reforestation projects, can inspire broader initiatives, influencing policy at national and international levels. These examples remind us that even the smallest actions can reverberate far beyond their origin, influencing the shape of the world we all share. But interconnection is not without its challenges. In a world so tightly woven, how do we balance individual needs with collective responsibilities? How do we ensure that the actions we take, no matter how well-intentioned, strengthen rather than strain the web of life? These are questions that demand careful reflection, but they also offer a powerful opportunity to live with awareness, compassion, and purpose. As we acknowledge the profound ways we are connected, one thing becomes clear: the choices we make matter. Whether it's in how we treat the planet, how we interact with others, or how we approach the challenges of our time, our actions ripple outward, shaping the interconnected web of existence. Let's now explore the practical implications of this understanding and consider how we can act in ways that honor and sustain the connections that bind us all. The realization that everything is interconnected is more than a philosophical or scientific insight, it's a call to action. This understanding transforms how we relate to the environment, to each other, and to ourselves. It urges us to take responsibility for the threads we touch, knowing that our actions can reverberate far beyond our immediate surroundings. Take the environment, for example. Every ecosystem is an intricate web of interdependence, and any disruption in one part of the system has consequences for the whole. Deforestation in the Amazon affects global weather patterns. Plastic waste dumped into the ocean doesn't just pollute the water, it breaks down into microplastics that enter food chains and eventually our bodies. These examples remind us that environmental harm in one region is never truly isolated, it ripples outward, affecting people and ecosystems worldwide. Recognizing this, global challenges like climate change or biodiversity loss demand collective action. Initiatives such as the Paris Agreement reflect an acknowledgement of interconnection, bringing nations together to address shared threats. Yet the responsibility doesn't rest solely on governments or institutions. Individual actions reducing waste, supporting renewable energy, planting trees can contribute meaningfully to global solutions. Each choice, however small, becomes a thread in the greater tapestry of change. But interconnection isn't only about the natural world. It's also about the choices we make in our relationships and communities. In a connected society, even minor acts of kindness can have profound effects. A simple gesture of empathy can inspire others to do the same, creating a ripple of positivity that extends far beyond its origin. On a larger scale, grassroots efforts, community cleanups, volunteer programs, or social campaigns demonstrate how collective action can lead to meaningful change. These ripples may start small, but they have the potential to grow, influencing policies, cultural norms, and even global movements. Technology amplifies these connections in powerful ways. Social media, for instance, allows ideas to spread at unprecedented speed. A single post can inspire millions to take action, whether it's raising funds for disaster relief or mobilizing support for social justice causes. At the same time, technology also poses challenges, such as the spread of misinformation or the environmental cost of digital infrastructure. Acknowledging interconnection means using these tools responsibly, ensuring that they strengthen the web rather than weaken it. This understanding also challenges us to think differently about responsibility. In a fragmented worldview, it's easy to feel isolated, to believe that individual actions are insignificant in the face of global issues. But interconnection reveals a deeper truth. Every action matters because it is part of a larger whole. This doesn't diminish individual importance, it amplifies it, showing how small, mindful choices contribute to the collective good. With this shift in perspective, we begin to see the world not as a series of isolated problems, but as a dynamic, interwoven system. Environmental stewardship becomes a moral imperative, not because of abstract principles, but because our survival and well-being are directly tied to the health of the planet. Collaboration and compassion become essential in addressing social challenges, not as acts of charity, but as expressions of the fundamental truth that our lives are intertwined. Yet, interconnection also calls for balance. It's easy to feel overwhelmed by the vastness of the web, by the weight of realizing that every action matters. The challenge lies in finding agency within this complexity. We don't need to solve every problem or touch every thread. Instead, we can focus on the parts of the web closest to us, trusting that our contributions will resonate outward. This is the power of interconnection. It reminds us that we are never truly alone, that every action has meaning, and that together we weave the fabric of existence. But not everyone sees it this way, and this understanding is not without its challenges. Let's turn to the critiques and difficulties of embracing interconnection and explore how they shape our understanding of this profound concept. While the idea of interconnection is compelling, it is not without its skeptics and challenges. Critics often question whether all connections are meaningful, or if humans are simply pattern-seeking creatures, prone to finding links where none exist. It's a valid concern. Our brains are wired to make sense of the world, to organize chaos into familiar patterns, even when those patterns might be coincidences. Consider how we might see a streak of good luck as a sign of destiny, or interpret unrelated events as having a deeper, hidden connection. Is interconnection truly real, or are we assigning meaning to randomness? This skepticism is compounded by the limits of human perception. Even if the universe operates as a connected system, our ability to comprehend it is inherently restricted. The scales of interconnection, ranging from the quantum to the cosmic, are far beyond what our senses or intuition can grasp. Quantum entanglement, for example, defies everyday understanding, as particles communicate instantaneously across vast distances. Similarly, ecosystems and weather patterns are governed by such intricate dynamics that even our most advanced models struggle to predict them with precision. Another challenge lies in the practical application of interconnection. While it's easy to embrace the idea on a philosophical level, turning it into actionable change is far more complex. Global collaboration often falters in the face of competing interests. Climate agreements, for instance, reflect the difficulty of aligning nations with differing priorities, resources, and responsibilities. Even on an individual level, the emphasis on personal responsibility can sometimes feel overwhelming. If every choice matters, how do we avoid being paralyzed by the weight of our decisions? How do we reconcile the vastness of our potential impact with the smallness of our everyday lives? Scientific exploration of interconnection also faces its own hurdles. While quantum entanglement is well documented, its application to larger systems remains speculative. Can the principles of quantum mechanics truly explain interconnection on human or societal scales? Chaos theory, too, reveals the complexity of dynamic systems but leaves many questions unanswered. For example, while we understand that small changes can lead to massive effects, predicting or controlling these outcomes remains elusive. Philosophically, interconnection raises tensions between unity and individuality. If all things are one, where does that leave personal identity and autonomy? This question is particularly challenging in societies that value individualism. Balancing the needs of the collective with the rights of the individual is a delicate task, one that becomes even more complicated when applied to real-world issues like governance, resource distribution, or cultural preservation. There's also the risk of feeling powerless in the face of such vast systems. Acknowledging interconnection can evoke awe and wonder, but it can also inspire a sense of insignificance. How much influence does one person truly have within such an intricate web? This tension between agency and complexity is one of the central challenges of embracing interconnection as a guiding principle. Despite these critiques, the idea of interconnection remains a powerful lens through which to view the world. It's not about proving every connection or solving every problem. Instead, it's about cultivating curiosity, humility, and a willingness to engage with the complexity of existence. Even when the web seems too vast to comprehend, each thread we touch still resonates. As we grapple with these challenges, it becomes clear that they are not obstacles to interconnection, but part of its profound mystery. They remind us that understanding the universe and our place within it is an ongoing process, one that invites us to think deeply, act consciously, and remain open to the unknown. With this perspective, let us now reflect on the journey we've taken and draw it together in a final contemplation of the web of existence. As we reach the conclusion of this exploration, it's worth pausing to reflect on the journey we've undertaken. We began with a simple yet profound question: are all things truly connected? Along the way, we've unraveled threads from the fabric of science, philosophy, and human experience, each revealing a different facet of the web of existence. In the realm of science, quantum entanglement showed us how particles, separated by vast distances, can remain mysteriously linked, challenging our understanding of time, space, and causality. Nature's ecosystems demonstrated that interdependence isn't a theoretical idea, but the foundation of life on Earth, where the health of a bee can ripple outward to affect entire food systems and climates. The butterfly effect reminded us that small actions can lead to massive consequences, not only in physical systems but in human history and culture. Philosophy and spirituality echoed these truths, offering ancient metaphors like Indra's net to describe the unity of existence. Eastern traditions emphasized the interdependence of all things, while Western thinkers like Spinoza and Lovelock revealed a similar vision of interconnectedness through reason and science. Human societies, too, provided vivid examples of interconnection, from the spread of cultural memes to the shrinking world created by globalization and technology. This journey has also confronted us with challenges: the limits of human perception, the complexities of large systems, and the tension between individuality and unity all remind us that interconnection is not always easy to grasp or act upon. Yet these challenges don't diminish the significance of the web, they deepen it. They invite us to approach the world with humility, recognizing that we are part of something far greater than ourselves. So what does all this mean for how we live? Recognizing interconnection reshapes our understanding of responsibility. It teaches us that every choice we make, what we consume, how we treat others, how we care for the planet resonates far beyond its immediate context. This awareness isn't a burden, it's an opportunity. It allows us to act with intention, knowing that even small, thoughtful actions can contribute to a larger ripple of positive change. It also offers a new perspective on challenges. Problems that once seemed insurmountable, climate change, inequality, or even personal struggles, can be reimagined as shared endeavors. Interconnection reminds us that we are not alone, that solutions require collective effort, and that our individual contributions, however small, matter. But perhaps the most profound gift of interconnection is the way it shifts our sense of belonging. We are not isolated fragments, adrift in a cold, indifferent universe. We are threads in a tapestry, each part of a larger story. This realization brings both comfort and responsibility, comfort in knowing we are never truly alone, and responsibility in acknowledging that we shape the web through our thoughts, actions, and relationships. As we close, let's return to the question that began this journey: are all things truly connected? Science, philosophy, and human experience suggest the answer is yes. But more important than the answer is the question itself, for it invites us to see the world and ourselves with fresh eyes. If everything is connected, what will you do with this knowledge? How will it change the way you live, the way you think, and the way you contribute to the web of existence? The threads of the universe stretch infinitely in all directions. You are one of them. What kind of ripple will you create? Picture a night thousands of years ago. The sky stretches endlessly above, its vastness punctuated by an uncountable number of stars. Each one shines like a silent beacon, its light traveling across unimaginable distances to reach the eyes of our ancient ancestors. Around a glowing fire, a group of early humans gathers on an open plain. The night is still, except for the crackling flames and the rhythmic chirping of crickets. Faces, weathered and thoughtful, turn upward as if searching for answers written in the heavens. To these early observers, the stars were not mere points of light, but profound mysteries. They traced the patterns in the sky, creating maps and stories, finding order in what seemed like chaos. The stars were guides, both physical and spiritual, their movements marking the passage of seasons, and perhaps even the will of unseen forces. Beneath this canopy of celestial brilliance, one question has likely lingered in their minds: where did we come from? Their world was full of unanswered questions. Why does the sun rise and fall? What brings life into being? What lies beyond the shimmering expanse above? These early humans might not have had telescopes to peer into the heavens or equations to decode the universe's mechanics, but their awe and wonder were no less profound. For them, the stars represented a gateway, a connection to something far larger than themselves, something timeless. This moment of humans staring into the unknown captures a universal truth. No matter how much our tools and theories have advanced, the core questions remain the same. Who are we? What is our purpose in this vast expanse? These questions, as ancient as humanity itself, are the foundation of every myth, every philosophy, and every scientific pursuit. As we embark on this exploration, let us remember those early stargazers. Their wonder and curiosity set humanity on a journey that continues today. Their search for meaning beneath the stars has led us inward to the microscopic codes within ourselves. And while we now have the power to analyze our DNA and map the stars, the deeper question still resonates. Are we simply biological beings, or do our origins hint at something greater? This is where our journey begins. Under that same night sky, we find ourselves still searching, still asking. Perhaps hidden within the strands of our DNA lies the answer to the eternal question of what it means to be human. It is a deceptively simple question: who are we? Yet, beneath its simplicity lies a profound complexity. This is not merely a question of identity or biology. It is the ultimate inquiry into our place in the universe, one that has persisted across millennia and disciplines: philosophy, religion, and now science. This question transcends time because it touches every aspect of our lives. From the way we perceive ourselves and others to how we navigate relationships, make decisions, and construct societies, our answer to who are we forms the foundation of our reality. It shapes the myths we tell, the laws we write, and even the scientific theories we construct to explain our existence. Philosophers like Socrates and Descartes wrestled with this question, tying it to notions of consciousness and self-awareness. Religions have offered divine narratives, portraying humans as creations imbued with purpose by higher powers. Today, science approaches this age-old inquiry through a new lens, the study of DNA, the molecular blueprint of life. But while science has given us tools to decode the mechanics of life, the deeper why remains elusive. Does the intricate design of our DNA reflect pure chance, the unfolding of natural laws, or the fingerprints of an intentional designer? This convergence of science and philosophy is where the heart of the question lies, inviting us to look not only outward to the universe, but inward to the very essence of our being. DNA is more than a biological code, it is the thread that connects all living things. Within its structure lies not only the key to our physical traits, but also the story of our evolutionary journey. Scientists call it the language of life, and like any language, it can be read, interpreted, and questioned. What makes DNA extraordinary is its universality and precision. From the humblest single-celled organism to the complexity of the human brain, this molecule governs life in all its forms. Yet, it also raises profound spiritual and philosophical questions. If DNA is a code, then who or what is the coder? Does its intricate design suggest a randomness born of chaos, or does it point to an underlying purpose? DNA serves as a bridge between the tangible and the intangible. It grounds us in the biological reality of our existence, while hinting at something larger, a connection to the cosmos, to history, and perhaps to something divine. This duality makes the study of DNA not just a scientific pursuit, but a deeply human one, touching on the spiritual longing for meaning that has driven our species since its inception. In our quest to understand existence, science and philosophy often seem like opposing forces, one focused on facts and mechanisms, the other on meaning and purpose. Yet when we examine DNA, these two disciplines converge in a way that is both surprising and profound. Science tells us that DNA is a molecule, its structure painstakingly mapped by the Human Genome Project. But philosophy asks, what does it mean that such a molecule exists at all? Why does DNA carry the capacity to create beings capable of asking these very questions? This intersection invites us to think beyond reductionist explanations of life and consider the possibility that our origins and purpose are intertwined in ways we have yet to fully comprehend. As we unravel the mysteries of DNA, we are not merely exploring the mechanics of life, we are engaging with questions that define the human experience. What is the nature of our individuality if our DNA connects us to all life? If DNA holds the code for our physical existence, does it also encode hints about our spiritual essence? These questions transcend disciplines, inviting scientists and philosophers alike to grapple with the ultimate mystery. What does it mean to be human? Let's descend from the stars into the microscopic world inside every one of us. Within each cell of your body lies a remarkable molecule, a spiraling ladder-like structure that carries the instructions for life itself. This is DNA, deoxyribonucleic acid, the building block of all living organisms. Encoded in its sequences are the blueprints that define our physical traits, regulate our bodily functions, and even influence how we adapt to the world around us. DNA structure was first uncovered in 1953 by James Watson and Francis Crick, a discovery that forever altered the way humanity understands itself. The now iconic double helix, the twisting ladder of paired nucleotides, is not just a chemical structure, it's an archive of life's history. It contains instructions for making everything in the human body, from the proteins in your muscles to the neurons in your brain. Each strand, coiled tightly into chromosomes, holds a staggering amount of information, over 3 billion base pairs arranged in a precise, coded sequence. Yet, despite its complexity, DNA is astonishingly efficient. Imagine a library where every book is stored in code, taking up virtually no physical space, but containing the knowledge of entire civilizations. This is the level of mastery inherent in DNA. But like any library, it also holds mysteries we are only beginning to decipher. For decades, Scientists believed that understanding DNA would explain the evolutionary journey of life on Earth, from simple single-celled organisms to the intricate beings we are today. And indeed, much has been uncovered. But as we've mapped the human genome, one mystery has persisted: what makes humans fundamentally different from our closest relatives, such as chimpanzees, whose DNA is 98.5% identical to ours? One key lies in the FOXP2 gene, often referred to as the language gene. This tiny segment of DNA underwent a rapid and precise mutation roughly 200,000 years ago, coinciding with the emergence of anatomically modern humans. Unlike the gradual changes typically associated with evolution, FOXP2 seems to have shifted dramatically, enabling the development of complex language, a trait that sets us apart from all other species. But it's not just language. Our evolutionary story contains peculiar anomalies. The reorganization of human chromosome 2, for instance, involved the fusion of two separate chromosomes in a way that appears deliberate, as though tailored for specific functions. This change is not easily explained by traditional Darwinian mechanisms. These rapid and precise shifts challenge the notion that all genetic changes are random and slow. Could there be a deeper force at play in our evolution? A closer look at the human genome reveals another enigma. Compared to our primate relatives, such as chimpanzees, we have fewer chromosomes, 46 instead of 48. At first glance, it seems as though we're missing something. However, scientists discovered that our second chromosome is, in fact, a fusion of two ancestral ape chromosomes, now seamlessly combined into one. What's remarkable is not just the fusion itself, but the precision with which it occurred. This event appears to have been optimized for human development, affecting traits such as brain size and function. It's as if our genetic code was rewritten with purpose, aligning with the rapid emergence of traits that make us distinctly human. These discoveries open a provocative question. Are these genetic anomalies the result of chance, or do they hint at some kind of intentional design? While science continues to search for answers, these anomalies challenge the purely mechanistic view of evolution and invite us to reconsider the narrative of our origins. We've explored the biological framework that defines our existence, but DNA is more than a molecule of life. It is a story, one written in code, shaped by time, and possibly guided by forces beyond our understanding. As we delve deeper, we must ask, what does this code mean? Is it merely a record of biology, or does it carry a message about who we are and why we exist? In the next chapter, we'll move beyond the boundaries of science to explore the philosophical and spiritual implications of our genetic heritage. Is DNA just a collection of biological instructions, or does it carry something deeper, a message about who we are and why we exist? At its core, DNA is a molecular marvel capable of orchestrating the symphony of life. Yet, when viewed through a philosophical lens, it becomes more than a mechanism. It becomes a symbol of interconnectedness, a code that might hold insights into our purpose. Philosophers have long debated whether life has inherent meaning, or if meaning is something we impose upon the world. DNA complicates this debate. Its intricate structure and precise functions challenge us to ask, is it possible for something so elegantly designed to exist without intention? If DNA is a language as many scientists describe it, what or who wrote it? This question invites us to reframe how we think about life. Rather than seeing ourselves as accidents of evolution, could DNA suggest that life itself is part of a greater design? And if so, what role do we play in this design? These inquiries push us beyond biology, forcing us to confront the boundaries between science and spirituality. Few topics spark as much controversy as the idea of intelligent design. The notion that life's complexity could be the result of purposeful creation often clashes with the prevailing scientific view of random mutation and natural selection. Yet DNA presents anomalies that are difficult to explain through randomness alone. For instance, consider the FOXP2 gene, often called the language gene. Its rapid and precise mutations enabled humans to develop complex speech, an ability that transformed our species. This kind of genetic leap is rare and defies the slow, incremental changes typically associated with evolution. Was this a random event, or does it hint at some guiding hand in our development? Then there's the fusion of human chromosome 2, a genetic event that fundamentally distinguishes us from other primates. This fusion didn't just happen, it appears optimized for human functionality, affecting traits like brain size and cognition. Such precision raises profound questions. Could these changes be evidence of intervention, whether by a divine force, a higher intelligence, or a process we have yet to understand? While science may not yet have definitive answers, these anomalies challenge the assumption that life's complexity is purely the result of chance. They invite us to entertain the possibility that our existence is part of a larger, intentional framework of proposition that blurs the line between science and philosophy. If DNA is a code, does consciousness influence how it is expressed? This is not merely a hypothetical question, it is one grounded in the emerging science of epigenetics. Research has shown that our thoughts, emotions, and environment can directly impact gene expression, altering how our DNA functions without changing its fundamental structure. This revelation has profound philosophical implications. It suggests that we are not passive recipients of our genetic inheritance, but active participants in shaping our biology. Our consciousness, the way we think, feel, and perceive the world, interacts with our DNA in ways that science is only beginning to uncover. Philosophers and spiritual traditions have long posited that the mind and body are deeply interconnected. The findings of epigenetics provide a scientific basis for this belief, showing how practices like meditation, gratitude, and compassion can influence our physical health by altering gene expression. It's as if DNA responds not just to chemical signals, but to the quality of our inner lives. This interplay between consciousness and biology raises profound questions about free will and purpose. If we can influence our DNA through our thoughts and actions, what does that say about our role in the universe? Are we co-creators of our existence, shaping not only our lives but the evolutionary trajectory of our species? As we delve deeper into the mysteries of DNA, it becomes clear that this molecule is more than a biological blueprint. It is a bridge between science and spirituality, between the physical and the metaphysical. In the next section, we will explore how ancient wisdom and modern science converge to reveal the extraordinary potential encoded within us. If DNA is both a code and a message, then perhaps it is time to decode not just what it says about life, but what it says about the universe and our place within it. Across cultures and centuries, ancient traditions have described a deep interconnectedness between humans, the earth, and the cosmos. Indigenous peoples spoke of the web of life, a network binding all living things. Mystical traditions referred to the universe as a single, conscious entity. These ideas, once dismissed as metaphysical speculation, now find echoes in the discoveries of modern science. Quantum physics reveals a universe where particles remain connected across vast distances, a phenomenon Einstein famously called spooky action at a distance. This interconnectedness extends to us as well. Each atom in our bodies is forged in the heart of ancient stars, making us literal children of the cosmos. DNA, in this context, becomes not just a biological molecule, but a thread in the fabric of existence, connecting us to the universe in profound and tangible ways. Ancient wisdom described this unity in spiritual terms, while science now offers a complementary perspective. Both point to the same truth. We are not separate from the universe, but deeply embedded within it. The DNA in our cells is both a product of cosmic forces and a key to understanding our place within the larger whole. Recent experiments suggest that DNA is not as static as once thought. Research shows that emotions, particularly positive ones like gratitude, compassion, and love, can influence the way DNA expresses itself. For example, studies conducted by the HeartMath Institute revealed that human emotions could alter the physical structure of DNA in laboratory conditions. When participants focused on feelings of anger or frustration, DNA strands tightened, reducing their ability to function effectively. Conversely, when participants cultivated feelings of appreciation and love, the DNA relaxed, becoming more functional and efficient. These findings suggest that DNA is not just a biological constant, but a dynamic entity that responds to the quality of our inner lives. This connection between emotion and DNA challenges traditional scientific paradigms. It suggests that our consciousness is not merely a byproduct of biology, but an active force capable of influencing the very molecules that define us. From a spiritual perspective, this interplay between emotion and DNA reinforces the ancient belief in the transformative power of love and compassion. Perhaps the most startling evidence of DNA's influence on the universe comes from experiments examining its interaction with light. Photons, the basic particles of light, are influenced by the presence of DNA, aligning themselves along the strands of the molecule in ways that defy randomness. Even after the DNA is removed, the photons remain organized, as though the molecule imprinted its structure onto the surrounding space. This phenomenon suggests that DNA does not merely exist within the universe, it actively interacts with it, shaping its environment in subtle but profound ways. In philosophical terms, this raises questions about the role of DNA as a conduit between the physical and metaphysical. Could it be that DNA, through its interaction with light, serves as a bridge between the material world and the energetic field described in quantum physics? Such ideas challenge conventional boundaries between science and spirituality. They invite us to consider that DNA, far from being a passive blueprint, is an active participant in the cosmic dance of energy and matter. This perspective aligns with ancient spiritual teachings, which often portrayed humans as microcosms of the universe, capable of reflecting and influencing the greater whole. As we uncover these connections between DNA, emotion, and the cosmos, we are faced with profound questions. What potential lies dormant within our genetic code? How might understanding DNA's interaction with light and emotion transform the way we live, heal, and evolve? In the next section, we will explore how advancements in technology and shifts in consciousness could shape the future of humanity, unlocking capabilities we have only begun to imagine. Advancements in genetic technology, such as CRISPR-Cas9, have opened the door to possibilities once confined to the realm of science fiction. This revolutionary tool allows scientists to edit DNA with unprecedented precision, potentially erasing genetic diseases, enhancing physical traits, or even extending the human lifespan. We are no longer passive inheritors of our genetic blueprint, we are becoming its architects. But with this power comes profound ethical dilemmas. Should we use gene editing to enhance humans beyond their natural limits? What risks do we face in tampering with the delicate balance of evolution? Could we inadvertently create a divide between those with access to genetic enhancements and those without, deepening existing social inequalities? More provocatively, could the technologies we create to edit DNA also unlock dormant potential encoded within it? Traits such as heightened intelligence, resilience to disease, or even latent psychic abilities have been theorized. If these possibilities exist, they challenge us to rethink what it means to be human and whether evolution is a process we should guide or let unfold naturally. Beyond technology, the growing field of epigenetics reveals that we already possess some control over our evolution. Environmental factors, lifestyle choices, and even our thoughts and emotions influence how our genes are expressed. This means that our behaviors today can shape not only our own lives, but potentially the genetic legacy we pass to future generations. Consider practices like meditation and mindfulness, which have been shown to alter gene expression associated with stress and inflammation. These findings suggest that human potential is not limited by our genetic code, but is shaped by how we engage with it. If our consciousness interacts with our DNA, as emerging research suggests, then the boundaries between biology and spirit blur further. What if the key to human evolution is not external manipulation but internal mastery? By learning to harness the power of our minds and emotions, we may unlock abilities long considered superhuman, such as advanced healing, heightened intuition, or greater empathy. These traits, while rooted in biology, point toward a future where human evolution becomes a conscious and collaborative process. As we stand at this crossroads of technology, biology, and consciousness, a new narrative begins to emerge. For centuries, humanity has viewed itself as small and insignificant, a mere accident in an indifferent universe. But the discoveries of DNA and its interaction with the cosmos challenge this narrative, suggesting that we are neither insignificant nor accidental. Instead, we may be participants in a vast, unfolding story, one where the universe expresses itself through us. Our ability to reflect, question, and innovate is not a deviation from nature, but an integral part of it. The rapid advancements in genetic science, paired with deeper explorations of consciousness, invite us to embrace a vision of humanity not as isolated beings but as co-creators within the cosmos. The new human story is one of connection between science and spirituality, between our biological heritage and our spiritual aspirations, and between ourselves and the universe. It is a story that challenges us to take responsibility for our evolution, to act not out of fear or greed, but out of a profound respect for the interconnectedness of life. As we reflect on the past and look toward the future, one truth becomes clear: DNA is more than a biological molecule. It is a bridge, a connection between our origins and our potential, between science and philosophy, between the material and the spiritual. But this bridge is only as strong as our willingness to explore it. In the final section, we will bring together the threads of this journey, asking the ultimate question: if DNA holds the code for life, what will we choose to do with it? Over the course of this exploration, we have ventured into the depths of science, philosophy, and spirituality. We began with humanity's timeless question, who are we? And traced its echoes through the structure of DNA, the mysteries of evolution, and the interplay between biology and consciousness. We have seen how the double helix is not just a molecular blueprint, but a symbol of connection, linking us to the cosmos, to one another, and perhaps to something greater. DNA's complexity challenges the notion that life is an accident of randomness. From the rapid mutations of the FOXP2 gene to the fusion of human chromosome 2, its anomalies hint at a story far deeper than conventional science alone can explain. And as we've seen, emerging research into epigenetics and the DNA-photon connection suggests that our genetic code is not static, but profoundly responsive to our emotions, thoughts, and environment. We've also explored the transformative potential of technology, from CRISPR to gene editing, and the ethical questions it raises about the future of humanity. Yet, alongside these external tools, we've discovered an equally powerful internal capacity, the ability of consciousness to shape our biology and perhaps to guide our evolution. At the heart of this journey lies a bridge between the tangible and the intangible, the measurable and the immeasurable. Science gives us tools to decode DNA, revealing its role in building and sustaining life. Philosophy, however, asks us to reflect on what this knowledge means. Is DNA merely a mechanism for survival, or does it carry a deeper message about the nature of existence? Does it point to an underlying purpose, a design or a connection that transcends biology? This convergence of science and philosophy compels us to reconsider our place in the universe. We are not separate observers of a distant cosmos, but active participants in its unfolding story. Through our DNA, we carry the universe within us, its history, its potential, and perhaps its purpose. As we stand on the threshold of new discoveries, one question looms large. What will we choose to do with the knowledge of our DNA? Will we use it to manipulate life for short-term gain, or will we honor its complexity as a source of wisdom and connection? Will we view it merely as a biological code, or will we embrace its deeper implications, seeing it as a bridge to understanding our role in the cosmos? If DNA is a code, then it is one written with extraordinary precision and creativity. But every code requires a decoder. And so the ultimate question is not just about the nature of DNA itself, but about us. Are we willing to explore its mysteries with humility, curiosity, and an openness to its deeper meanings? This journey is not just about unlocking the secrets of life, it is about discovering what it means to be human. And as we move forward, perhaps the greatest revelation will not come from a laboratory or a telescope, but from the courage to look inward and reflect on the timeless question, who are we, and why are we here? The story of DNA is, in many ways, the story of us. It is a narrative of evolution, creativity, and connection, a mirror reflecting both our origins and our aspirations. As we close this chapter, let us not see it as an end, but as a beginning. A call to wonder, to question, and to embrace the profound mystery of existence. If the strands of DNA hold the code for life, then the next chapter is ours to write. What will you choose?
Have you ever had a day where you woke up feeling drained before even doing anything? No heavy lifting, no crisis. But somehow your energy's gone, like someone left the faucet running all night. It's easy to blame it on age, stress, or not sleeping well, and sometimes that's true. But more often than not, the problem isn't that you've run out of energy. It's that you're using it in ways that don't serve you. You're burning fuel just trying to stay in your own lane. Right now, at this exact moment, your body is alive with signals. Your skin feels the texture of your shirt. Your ears are picking up faint background sounds. Your nervous system is reading your posture, your breath, the light in the room. Your brain is tracking all of this and more without you even noticing. It's working overtime behind the scenes, filtering out anything that doesn't seem urgent. And that's the catch, because the same system that helps you focus is also quietly shutting out the parts of life where energy lives. Let's pause here. Most of us don't have an energy problem, we have an awareness problem. We walk through the day with our minds spinning in loops, memories, deadlines, problems to solve, and in that mental noise we lose connection to the body, to the moment, to what's actually here. It's like driving a car with the parking brake on. The engine's fine, the tank is full, but something's holding you back, and you don't even realize it. You weren't always like this. Think back to learning something new, riding a bike, swinging a bat, using a new tool. At first it felt weird. Your hands didn't know what to do, your body wasn't on the same page as your mind. But slowly, with repetition, it started to feel natural. What happened? You didn't just get better. Your brain literally reorganized itself to support what you were practicing. That's how energy flows. It follows the pathways you train, and if you've spent decades training stress, tension, and overthinking, guess what shows up? Disconnection, fatigue, frustration. The good news, you can change it. Your system already knows how to recharge. Your body already knows how to balance. You just have to stop interrupting it. Here's where it begins. Right now, take 5 seconds. Feel your feet on the floor. Feel your breath move in and out. Don't try to fix it, just notice. That's it. What you're doing in that simple act is redirecting your energy from autopilot into presence, not in a spiritual way, in a neurological way. Because the moment you shift your attention inward, you start accessing a deeper reservoir of energy that's been there all along. In the next section, we'll look at what this energy actually is, not in theory, but in real, observable terms. Because once you understand how energy works inside you, you'll stop looking for more of it and start unlocking what's already yours. Let's talk about energy, not in the vague, mystical sense, not as a buzzword. Let's talk about it in the most literal, physical way possible. Strip everything down. Your skin, muscles, bones, organs, and what's left? Atoms. But here's the wild part. Atoms aren't solid. They're 99.9999% empty space. What's in that space? Vibration, frequency, movement. What you think of as matter is just energy holding form. That means your body is energy. Your brain waves are energy. Your emotions, also energy. Electrical, chemical, hormonal shifts that move through your system like waves. So when you say, "I'm out of energy," what you really mean is, my system isn't flowing the way it's meant to. It's like a river that's been blocked by fallen trees. The water is still there, but it can't move, and when energy can't move, you feel stuck, heavy, tired, numb. But that also means something else. If your energy can get stuck, it can also get unstuck. And you don't need fancy rituals or equipment to do it. You just need to understand how to work with what's already in motion. Here's a simple truth. You are always interacting with energy. Most of the time, you're just not aware of it. You walk into a room and feel tension before anyone says a word. You meet someone and immediately sense trust or distrust without logic. You hear a song and your mood shifts in seconds. That's not imagination. That's energetic sensitivity. Your nervous system is reading signals beneath the surface. The question isn't whether you're tuned in. You already are. The real question is, what have you been trained to ignore? See, modern life teaches us to live from the neck up. We think our way through everything. We plan, we analyze, we solve. But in doing that, we lose connection to the rest of the system. Your body is constantly giving you data through breath, posture, heartbeat, tension, warmth, stillness. But if you're not paying attention, it gets filtered out. And when that happens over time, you become disconnected from your own energy field. You're still operating, still functioning, but only at a fraction of your capacity. It's like driving a high-performance car with the engine locked in first gear. Here's a way to test it. Right now, shift your attention to the space just around your body. Not your thoughts, not your muscles, just the space. Can you sense any tingling in your hands, any pressure around your head or chest, a subtle shift in warmth? Those signals are always there, but your mind's been trained to overlook them. You're not creating energy by doing this. You're simply noticing it for the first time in a while. This is the beginning of working with energy. Not in a mystical sense, but in a deeply practical one. Because the more fluent you become in sensing your own field, the more you can adjust it, not with effort but with awareness. You don't need to force your energy to move, you need to remove what's blocking it. That starts with attention, then intention, then practice, in that order. In the next section, we'll explore how your mind is shaping what you feel, not just emotionally, but physically. You'll see how the filters in your brain determine what you experience and how they can be changed, not by doing more, but by seeing more. Let's continue. Here's something most people never stop to consider. You don't see reality, you see what your brain allows you to see. Let that land for a moment. Everything you experience, from your surroundings to your sensations, even your sense of self, is filtered through a lens built from years of habit, memory, and belief. And that lens? It's selective. Your brain is bombarded with over 11 million bits of data per second, but it only lets through a few dozen. The rest, it throws away. Why? Because your brain isn't built for truth. It's built for efficiency. It wants to keep you safe. It wants to keep you familiar, and it wants to keep you focused only on what you've learned to care about. So it tunes out anything that doesn't fit your current model of the world. Think of it like this. When you buy a new car, you start seeing that model everywhere. Not because there are suddenly more of them, but because your brain just made them relevant. Before, they were invisible. Now, they pop out. This is called selective attention, and it's happening all the time. Not just with cars, but with people, opportunities, emotions, even with your own body. If you've been trained to see stress as normal, your brain will filter the world through that lens. If you've learned to expect disappointment, you'll start overlooking anything that doesn't match that story. And most importantly, if you've been conditioned to ignore subtle signals like shifts in energy, intuition, tension, or flow, your brain will filter those out too. The signal was always there, you just weren't tuned to it. Here's a strange but powerful example. If you shine blue light on a yellow banana, technically your eyes should see green, but your brain knows bananas are yellow, so it overrides the input. It doesn't show you what your eyes see, it shows you what it expects. That's how powerful the filter is. Now imagine that same filter applied to how you feel in your body. If you believe you're tired, your brain will downplay signals of vitality. If you believe you're stuck, your nervous system will tighten in ways that reinforce it. But here's the good news. What your brain learned to ignore, it can also learn to notice. And that changes everything. Let's do something right now. Take 5 seconds, look around the room. Slowly, notice textures, light, color, shadow. Now, close your eyes for a moment and ask yourself, what did I miss? Most people realize they were only half seeing, they were looking without noticing. That same principle applies internally. You go through the day experiencing tension, fatigue, or disconnect, but never really turning toward it. The more you practice this noticing, the more detailed your inner world becomes, not because it changed, but because you did. This is how you begin to reclaim your energy, not by doing more, but by seeing differently, because when you shift perception, you shift access, and when you shift access, you shift power. In the next section, we'll go even deeper into the observer effect. You'll see that you're not just watching your experience unfold, you're shaping it with every thought, focus, and breath. Let's get into it. Here's something that sounds like science fiction, but it's confirmed by physics, psychology, and your own experience. The moment you observe something, you change it. At the quantum level, this is called the observer effect. When scientists try to measure a particle's behavior, it doesn't act the same as when no one's watching. It's not just spooky theory, it's proven, repeated, and measurable. Tiny particles behave differently depending on whether or not they're being observed. So what does that have to do with your daily life? Everything. Let's bring it down to earth. Have you ever had pain in your body and it wasn't that bad until you focused on it? Or maybe you were feeling fine until you started thinking about being tired. You noticed it and suddenly it got bigger. The same happens with emotion. You catch a passing irritation, and the moment you name it, "I'm frustrated," you feel it spread like heat in your chest. That's not your imagination. That's the observer effect playing out in real time. But it doesn't just amplify what you notice, it can also transform it. Think about a moment where you stepped back from anger, not suppressing it, but seeing it clearly. This is just a part of me reacting. I don't have to follow it. That slight shift in awareness from being inside the emotion to observing it changes your relationship to it. Suddenly, you're no longer a puppet of that feeling. You're a participant in how it moves. That's real power. Here's the shift. You are not a passive spectator in your experience. You are part of the system, an active influence on what unfolds. Your attention is not neutral, it carries intention, even if you're not conscious of it. What you focus on becomes stronger, what you ignore becomes weaker, and what you observe with curiosity, not control, begins to move in more intelligent ways. Try something now. Take a breath. Let your body settle. Now bring your attention, not to your breath, but to the space around your breath. Not the inhale, not the exhale, but the stillness just before the inhale and just after the exhale. That's where presence lives, not in the doing, but in the space between. And when you observe that space, something strange happens. Your breath naturally deepens, your body softens. You didn't try to change anything, but something changed anyway. That's the observer effect. So what does this mean for your energy? It means that the moment you start paying attention to where your energy is stuck, tension in the jaw, pressure in the chest, weight in the limbs, you're already creating the conditions for it to shift. You don't have to fix it. You don't have to push. You just have to notice with intention. This is why energy practices aren't about magical techniques or superhuman focus. They're about the quality of your attention. A relaxed awareness is more powerful than a strained effort. A curious mind unlocks more than a controlling one, because the act of watching is also an act of creation. In the next section, we'll look at how your brain literally rewires itself based on what you observe and repeat, and how that unlocks energy patterns that once felt You're not stuck. You're just running old code. Let's learn how to write something new. Let's clear something up. You're not too old to change. Your brain didn't stop growing at 25. You're not locked into the patterns you've been running for decades. The science is clear. Your brain is adaptable every single day of your life. This isn't motivation talk. It's hard neuroscience. It's called neuroplasticity, your brain's built-in ability to rewire itself based on how you think, feel, move, and focus. Let's break it down. Every time you repeat a thought, a behavior, or even a posture, you strengthen a connection in your brain. It's like hiking through grass. At first, there's no path, but the more you walk the same trail, the clearer it becomes. Eventually, it turns into a road, then a highway. That's how habits form. Not just behavioral habits, energetic and emotional ones too. If you've spent years carrying tension in your shoulders, worrying about the future, suppressing how you feel, ignoring your body, your brain has made those things normal. Not good, not bad, just familiar. And familiar equals default mode. The good news? You can build new defaults. You can train your brain to prioritize presence over pressure, clarity over chaos, flow over force. But here's the key. You don't do it by pushing harder. You do it by repeating different inputs with intention. Think of learning to play an instrument. At first, it's awkward. Your fingers don't cooperate, your timing is off, but you keep at it. You don't force mastery, you build patterns. Through focus, feedback, and repetition, your nervous system adjusts, and over time, what was clumsy becomes natural. Energy awareness works the same way. Let's test something now. Sit still. Bring your attention to your body, not just one part, but the overall sense of how it feels. Now, slowly scan. Is there tension in your jaw? Are your shoulders lifted without realizing it? Are your legs clenched even while sitting? Now, release just one of those. No big effort, just a small letting go. That's not a stretch. That's not a breathwork hack. That's your nervous system repatterning in real time as soon as you bring awareness to it. You do that consistently, and the brain takes notice. It starts to say, oh, we don't need to hold that tension anymore. We don't need to rush through every moment. We don't have to filter out calm or ease or energy. It rewires, bit by bit, not all at once, but layer by layer, just like how it built your old patterns. And this is important. Rewiring doesn't require perfection. It requires consistency. 10 seconds of clear attention is worth more than an hour of forced focus. Awareness with softness rewires faster than control with pressure. In the next section, we'll talk about what happens when you stop fighting your energy and start cooperating with it. Because the truth is, your system already knows how to heal, how to move, how to flow. You've just been getting in the way. Let's change that. Let's talk about something most men are never taught. You don't need to fight harder, you need to align better. We've been conditioned to believe that more effort equals more results. Push through, power up, grind it out. And yes, there's value in discipline, in strength, in showing up when it's hard. But when it comes to energy, especially the kind that fuels your inner world, force is the wrong tool, because energy doesn't respond to pressure, it responds to permission. Picture this. You're standing in a river. The current is strong. You want to move forward. You have two options. One, fight the current, struggle, waste strength trying to overpower the water. Two, step into the flow. Let the current carry you while you guide your direction. Most people live in option one, tension, resistance, burnout. But energy wants to move. If you stop blocking it, let's go deeper. Everything in your body, from your heartbeat to your hormones to your breath, is part of a system that thrives on rhythm, not rigidity. Your lungs expand and contract, your muscles contract and release. Even your thoughts cycle waves of attention and rest. Trying to fix your energy by forcing focus or ignoring fatigue, that's like holding your breath and wondering why you feel dizzy. True energy control isn't control at all, it's cooperation. Think of a surfer. He doesn't move the wave, he studies it, times it, aligns with it, then rides it with minimal effort, maximum intelligence. That's the same posture you need with your own energy. Not dominance, not avoidance, just attunement. Let's bring this into daily life. Ever tried to solve a problem late at night, exhausted, forcing yourself to think? You pace, you pressure, you grind, and nothing comes. But the next morning, calmer, clearer, the answer arrives with ease. That's energy intelligence at work, not doing more, but working with the moment. You can apply this same principle to your body. Try this. Close your eyes for a few seconds. Bring your attention to your breath, not to change it, just to track it. Then ask, where is the breath moving freely? Where does it feel tight or shallow? What happens when you simply notice without trying to fix? More often than not, the moment you stop interfering, the system begins adjusting on its own. That's how self-regulation works. Not through force, through space. There's a reason ancient practices like Tai Chi, Qigong, martial arts and breathwork all center on working with energy, not wrestling it. They weren't built on fantasy, they were built on observation. Thousands of years of watching how the body, breath and mind interact when brought into alignment, and all of it points to the same truth. Energy flows where resistance fades. Energy stabilizes when awareness returns. Energy renews when effort stops being the answer. This doesn't mean you stop working hard, it means you start working smart, especially with yourself. The mind is powerful, yes, but it's most powerful when it listens to the body, not when it bulldozes over it. In the next section, we'll explore what might be the biggest illusion of all, the belief that you're separate from the energy you're trying to control. Because the moment you stop seeing yourself as an outsider is the moment you stop chasing alignment and start embodying it. Let's take that step together. Most people go through life feeling like they're on the outside, separated from peace, from power, from clarity. It's the unspoken mindset we're handed from a young age. You have to go out there and find it, work for it, fight for it, chase it. Success, confidence, purpose, even energy. We're taught that it's somewhere else and we have to earn it. But what if the real shift isn't chasing harder, but realizing that you've never been separate from what you seek? Think about this. You're not living on top of the earth, you're living within it. You breathe its air, you drink its water. The calcium in your bones, the iron in your blood, they came from the stars, literally. Supernova debris built into your body. You're not standing apart from the system, you are the system, one expression of it, in human form. That's not philosophy, that's biology, that's physics. And yet, most people live like outsiders to their own lives. We treat energy like a tool we have to plug into, like it's somewhere else, out there, beyond reach. But the truth is far more powerful. You are energy, your thoughts are vibrations, your emotions are currents, your breath is a tide, your body is a field of shifting signals, always in motion. The illusion is thinking you have to do something to become part of it. You're already in it. You always have been. So here's the invitation. Stop standing at the edge of the river trying to control the current. Step in, feel the movement, let it carry you. Then guide your direction from within the flow. Because when you stop resisting life's natural rhythm, you don't lose power, you gain access. Here's a practice for today. Take a moment. Sit quietly. Don't focus on breath or body. Instead, focus on space. The space in the room, the silence between sounds, the stillness underneath your thoughts. Now ask yourself, where do I end and the world begins? Where does my energy stop and everything else start? If you really tune in, the boundary gets blurry. You start to feel less like a separate self and more like a wave on the ocean, not apart from it, part of it. That's not disempowering, it's liberating, because it means you don't have to hold it all together. You just have to remember you're not alone in it. The most powerful people, athletes, artists, leaders, they don't control energy like a puppet master. They move with it, they learn its language, they listen, they adjust. And when the moment comes, they act from connection, not tension. You can do the same, not by becoming someone else, but by letting go of the idea that you're separate from what already lives inside you. You've made it this far, not just through the words, but through the process of remembering, because none of this is new. Your body already knows how to align, your breath already knows how to balance, your mind already knows how to shift. You just needed space to hear it again. So now the question becomes, what do you do with this? It's tempting to want a big change, some lightning bolt moment where everything clicks and nothing's the same. But energy doesn't work like that. It works in rhythm, in small movements, in subtle awareness, in choices made again and again, even when no one's watching. You don't need to redesign your life in one day. You need to start noticing, consistently, gently, honestly. That's where the real power lives. Here's how you begin. Step 1. Anchor yourself in the body. A few times each day, stop what you're doing for 10 seconds. Feel your feet. Notice your shoulders. Check in with your breath. Not to change it, just to witness it. No drama, no performance, just presence. You're telling your system, I'm here, I'm listening, let's reset. Step 2. Use your attention like a tool. You now know that what you focus on, you amplify, so start directing your attention on purpose. If you're feeling overwhelmed, bring it to your breath. If you're scattered, bring it to one simple action. If you're numb, bring it to sensation. Your hands, your chest, the space around you. This is how you reclaim energy without forcing it. Step 3. Choose rhythm over rigidity. You're not a machine, you're a living system, designed to rise, fall, reset, and rise again. Don't expect non-stop intensity. Don't chase peak state all day. Instead, find your natural tempo. Work, rest, reflect. Action, pause, integration. You'll get more done with half the stress, and you'll feel better while doing it. Step 4. Practice awareness without judgment. This is key. Most people stop themselves before they even begin because they expect mastery instead of progress. You're going to get distracted, you're going to fall back into old patterns, you'll forget, then remember, then forget again. Good. That's part of it. Each time you come back, without shame, without story, you reinforce the path. Over time, that path becomes a new default, and that's how change becomes real. Step 5. Live the question. Don't rush for answers. Instead, hold this question in your daily life. Where is energy trying to move in me right now, and what's getting in the way? Sometimes the answer is physical, tightness, fatigue. Sometimes it's emotional, old frustration, fear, grief. Sometimes it's mental, overthinking, resistance, expectation. You don't need to fix it, you just need to listen. That listening is the healing. So here we are. You've learned that your energy isn't missing, it's misdirected. That your brain is filtering your reality, and you can rewire what it notices. That your attention is not passive, it's powerful. That you're not separate from energy, you are made of it. Now you begin to live it, not as a theory, but as a daily return to presence, to rhythm, to awareness. Because the truth is, you don't need more energy, you need fewer blocks, and you don't need to force yourself into becoming someone new. You just need to stop forgetting who you already are. The door is open. Take the first step. Throughout history, humanity has stood at the precipice of profound discoveries, each challenging the foundations of our understanding and reshaping the course of civilization. The Earth was once believed to be the center of the cosmos until revolutionary minds dared to see beyond conventional wisdom. Electricity, gravity, and even the very fabric of time and space, once mystical and unknowable, are now harnessed as essential components of our daily existence. Yet, as much as we have uncovered, the universe remains an enigma, concealing secrets that defy our current grasp of reality. What if the greatest breakthroughs are not about discovering something entirely new, but about reinterpreting what we already know? The forces that govern our universe, from the smallest quantum fluctuations to the vast curvature of space-time, may not be as disparate as they seem. Perhaps the key to unlocking the future of humanity lies not in fragmented disciplines, but in a unified vision, one that sees the cosmos, energy, and even consciousness as deeply interconnected elements of a single boundless system. For too long, scientific progress has been constrained by rigid paradigms, dismissing ideas that do not fit within established frameworks. But true evolution, whether in thought, science, or society, has always emerged from those willing to challenge the status quo. Now we stand once again on the brink of transformation, where a new perspective could illuminate a future far beyond our imagination. What if we have only scratched the surface of our potential? What if the very structure of space holds an untapped reservoir of energy? What if gravity itself is not an immutable force, but a phenomenon that can be understood, influenced, and even harnessed? These questions are not mere philosophical musings. They hold the potential to redefine the way we interact with our world, our technology, and the universe itself. The time has come to awaken to a deeper reality, to see beyond what we have been taught, and to embrace a more profound connection with the cosmos. This is not just a shift in knowledge, it is a transformation of perspective, one that could propel humanity into a new era of limitless possibility. Space is not empty. It is teeming with energy, structure, and potential. What appears to be a vast void is in fact a dynamic and intricate field of fluctuating forces, an invisible framework that underpins all of existence. Modern physics has revealed that the vacuum of space is not a passive absence, but a seething ocean of quantum activity, where particles blink in and out of existence and energetic currents ripple across the cosmos. Within this apparent nothingness lies a profound and untapped potential, an unseen architecture that may hold the key to unlocking entirely new forms of energy, motion, and interaction. Rather than a barren expanse separating celestial bodies, space functions as the very fabric of reality, a medium through which fundamental forces operate and shape the universe. The structure of the vacuum is not uniform, but exhibits fluctuations, densities, and complexities that influence everything from the movement of galaxies to the interactions of subatomic particles. If we learn to understand and manipulate these hidden dynamics, we may gain access to principles of propulsion, energy generation, and even gravitational control that could redefine the limits of human capability. The notion that space itself holds energy is not merely theoretical. The concept of zero-point energy suggests that even in the coldest, emptiest reaches of space, an immense reservoir of energy exists, one that, if harnessed, could revolutionize our technological landscape. What if the key to infinite, sustainable energy does not lie in burning fuels or splitting atoms, but in simply learning to access the latent power of space itself? The universe may not be as distant or indifferent as we once believed. Instead, it is an active, interconnected web of energy, a cosmic blueprint waiting to be decoded. The concept of vacuum fluctuations and their role in shaping gravitational fields is one of the most intriguing discoveries in modern physics. Quantum mechanics suggests that even in the apparent emptiness of space, fleeting bursts of energy and virtual particles spontaneously appear and disappear at microscopic scales. These fluctuations create a subtle but pervasive influence on the fabric of space-time itself, introducing an ever-present energy field that contributes to the fundamental structure of the universe. In classical physics, gravity is described as the warping of space-time by mass, but recent advancements propose that vacuum fluctuations may play a crucial role in this phenomenon. The temporary emergence and annihilation of virtual particles generate minute distortions in the structure of space, potentially affecting the way gravity operates at both quantum and cosmic scales. Some theories even suggest that these quantum fluctuations may be responsible for the emergence of mass itself, providing a link between gravity and quantum mechanics that could bridge the gap between Einstein's relativity and the principles of the subatomic world. If these fluctuations can be understood and harnessed, they may open new avenues for technological advancements beyond our imagination. The ability to manipulate the quantum vacuum could lead to revolutionary propulsion systems, gravitational shielding, and even methods of altering inertia and momentum without reliance on traditional energy sources. Instead of fighting against gravity with brute force, we may one day learn to work with it, using the hidden dynamics of the vacuum to achieve feats once thought impossible. The deeper we explore the nature of vacuum fluctuations, the closer we come to unlocking a profound and transformative understanding of the forces that shape reality itself. If we could manipulate these fluctuations, the implications for transportation, energy, and even human potential would be staggering. Imagine propulsion systems that defy conventional physics, allowing vehicles to traverse the globe or even deep space without fuel-dependent engines. Instead of being bound by the constraints of combustion and propulsion as we know it, a new class of motion could emerge, one that harnesses the latent energy of space itself, reducing friction and resistance to near-zero levels. In the realm of energy, mastering quantum fluctuations could mean the end of fossil fuels and reliance on finite resources. By tapping into the omnipresent quantum field, we could develop power systems that generate clean, boundless energy, forever changing the way civilization is sustained. The transition from limited extractive energy models to self-sustaining, universally accessible power sources would not only revolutionize industry, but also redefine global economies and the balance of technological progress. Beyond physics and engineering, the ability to control vacuum fluctuations could even have implications for human consciousness and biology. If space-time is a medium through which information and energy flow, could we learn to interact with it directly? Could consciousness itself be amplified, extended, or even liberated from its current limitations? These questions open the door to an entirely new perspective on what it means to be human, positioning us not as passive observers of the universe, but as active participants in shaping its very fabric. The mastery of these hidden forces could mark the dawn of a new era, one where the boundaries of reality are not just understood, but consciously navigated. Gravity at the cosmic level is well understood, yet at the quantum scale it remains a mystery. Gravity has long been regarded as one of the fundamental forces governing the universe, its effects shaping the orbits of planets, the formation of galaxies, and the bending of light across cosmic distances. Einstein's general relativity elegantly describes gravity as the curvature of space-time caused by mass, providing a model that has withstood rigorous testing at macroscopic scales. Yet, despite its success, gravity remains a stubborn enigma when examined at the smallest levels of reality. In the quantum realm, the predictable laws of relativity break down, giving way to a world of probabilities, wave-particle duality, and fundamental uncertainty, while the other fundamental forces, electromagnetism, the strong nuclear force, and the weak nuclear force, have been successfully integrated into the framework of quantum mechanics. Gravity resists such unification. Attempts to reconcile these two domains, such as string theory and loop quantum gravity, propose exotic solutions, but no definitive experimental validation has emerged. One of the greatest challenges in modern physics is understanding how gravity operates at the quantum scale. If space-time itself is not a smooth continuum but a fluctuating granular structure at the Planck scale, could gravity be an emergent force rather than a fundamental one? Could quantum fluctuations and the information encoded within space itself hold the key to bridging the divide between classical and quantum physics? These questions push the boundaries of our understanding, compelling us to rethink not only gravity, but the very foundation of reality itself. What if gravity itself is not a fundamental force, but an emergent property of space-time fluctuations? Rather than being a distinct force acting upon objects, gravity may arise as a consequence of deeper quantum processes occurring at microscopic scales. Some physicists propose that gravity emerges from the interactions of quantum information, encoded in the very fabric of space-time itself. If this is true, then space-time is not merely a passive stage upon which physical events unfold, but an active, dynamic medium shaped by the exchange of quantum data. This perspective challenges traditional views and opens new avenues for understanding gravity's elusive connection to quantum mechanics. It suggests that gravitational effects might be a macroscopic reflection of deeper, information-based principles operating at the smallest scales of reality. If gravity is indeed emergent, then by deciphering the quantum structure of space itself, we may one day unlock new ways to influence and control it. Such a shift in our understanding could lead to breakthroughs in propulsion, energy generation, and even the possibility of modifying space-time itself to enable unprecedented technological advancements. The concept of micro-black holes within particles, how this could replace the need for the strong force in physics. Emerging research suggests that what we perceive as fundamental forces might be manifestations of deeper, more intricate interactions within the quantum vacuum. The strong nuclear force, traditionally thought to be responsible for binding atomic nuclei together, may instead be an effect of ultra-small black holes residing within subatomic particles. If protons and neutrons harbor micro-black holes at their core, their immense gravitational influence could provide the binding force that holds atomic structures together, eliminating the need for an independent, strong nuclear force. This paradigm shift could lead to a more unified understanding of physics, integrating gravity seamlessly with quantum mechanics and redefining our approach to nuclear energy and stability. What if energy could be extracted from the fabric of space itself? If space is not truly empty, but instead a vast reservoir of quantum fluctuations and hidden energies, then it may be possible to develop technologies capable of drawing power directly from the vacuum. Unlike conventional energy sources that rely on matter-based fuel or chemical reactions, harnessing vacuum energy could provide an inexhaustible and clean source of power. Scientists have long speculated that zero-point energy, named for its presence even at absolute zero, might one day be converted into usable energy, fundamentally changing the way we power our world. If such an energy source could be controlled and efficiently extracted, the implications would be revolutionary. It could eliminate dependence on fossil fuels and end energy scarcity and enable a new era of technological advancement. Vehicles could operate indefinitely without refueling, entire cities could be powered without environmental cost, and deep space travel could become a reality without the burden of carrying massive fuel reserves. Unlocking the power hidden within space itself would not only reshape human civilization, but redefine our relationship with the universe at large. The Casimir effect and its implications for harnessing zero-point energy. The Casimir effect is one of the most tangible demonstrations of vacuum energy, illustrating how quantum fluctuations exert a measurable force even in the absence of matter. This phenomenon occurs when two parallel conducting plates are placed nanometers apart in a vacuum, creating a pressure differential due to virtual particles appearing and disappearing between the plates. The imbalance generates a force that pulls the plates together, revealing the hidden energy inherent in space itself. The implications of this discovery are profound. If vacuum energy can produce a measurable force at microscopic scales, could it be scaled up for practical energy applications? Scientists and engineers are exploring ways to harness this effect, envisioning new energy systems that tap into the fabric of space itself. The development of zero-point energy technologies could lead to the creation of highly efficient power sources capable of running indefinitely without fuel consumption or waste. Such advancements would mark a paradigm shift in energy production, eliminating the need for traditional power grids and revolutionizing transportation, industry, and space travel. If successful, these innovations could unlock the ability to extract limitless clean energy directly from the quantum vacuum, fundamentally altering our relationship with power generation and sustainability. The Casimir effect stands as a crucial stepping stone towards a future where humanity no longer depends on finite resources, but instead learns to harness the boundless energy woven into the very fabric of existence. If nature operates with such efficiency, could we replicate these principles to power the future? Nature has perfected the art of energy conservation and utilization over billions of years, relying on systems that are self-sustaining, highly efficient, and incredibly resilient. From the photosynthetic processes of plants converting sunlight into chemical energy with minimal waste, to the immense gravitational forces that drive stellar fusion, nature provides a blueprint for how energy can be harnessed and repurposed on an unprecedented scale. If we could decode and apply these mechanisms, we might uncover solutions far beyond our current technological limitations. By studying the way energy is stored and transferred in quantum systems, we could design artificial structures capable of tapping into the fundamental forces of the universe. The Casimir effect, quantum entanglement, and vacuum fluctuations all suggest that the universe itself holds an inexhaustible energy supply, waiting to be unlocked by a deeper understanding of its intricate mechanics. By learning from nature's ability to create equilibrium and sustainability, we could engineer revolutionary energy systems, ones that require no fossil fuels, emit no pollution, and operate continuously without entropy-induced loss. This would mark a turning point in human history, ushering in an era of abundance free from the limitations that have bound previous generations. If the universe itself thrives on efficiency and interconnected energy exchange, then the key to humanity's energy independence may not lie in extracting finite resources, but in learning to harmonize with the natural principles that sustain the cosmos. The cosmic connection: we are more than we think. Every element that composes the human body, carbon, oxygen, nitrogen, iron, originated in the heart of ancient stars. These celestial furnaces fused lighter elements into heavier ones through the process of nuclear fusion, gradually creating the building blocks of life as we know it. When these stars reached the end of their lifetimes, they exploded in magnificent supernovae, scattering these enriched elements across the cosmos. Over billions of years, these elements coalesced into new stars, planets, and ultimately the complex life forms that now populate Earth. This profound connection between humanity and the stars is not merely poetic, it is a scientific truth that reshapes how we perceive our existence. The iron in our blood, the calcium in our bones, the very air we breathe, all were once part of celestial bodies that burned brightly in the vast reaches of space. We are quite literally made of stardust, interwoven with the universe in a way that transcends time and distance. Recognizing this connection challenges the notion of separation. We are not isolated beings, confined to a single planet, but rather participants in a grand cosmic cycle where matter is continuously transformed and repurposed. The energy that flows through us has journeyed across galaxies, linking us to the birth of stars, the formation of planets, and the unfolding of life itself. If the universe has brought us into existence through such intricate and harmonious processes, what greater potential lies within us? Understanding our cosmic origins not only fosters a sense of unity with the universe, but also invites us to explore our own place within it. Could the same forces that created galaxies and nebulae be at work within us, guiding our evolution, shaping our consciousness, and unlocking abilities we have yet to discover? By acknowledging our celestial heritage, we begin to see ourselves not as mere inhabitants of Earth, but as cosmic entities, expressions of the universe itself, capable of transformation, exploration, and boundless discovery. The universe is not something separate from us. It is within us, around us, and flows through every atom of our being. As we continue to uncover its secrets, we may also come to understand the vast potential that lies dormant within ourselves. Modern physics suggests that our universe may not be what it seems. The holographic principle, a concept rooted in theoretical physics, posits that all information contained within a three-dimensional space can be fully described by data imprinted on a lower dimensional boundary. This theory first emerged from the study of black holes, where researchers discovered that the information about everything falling into a black hole could be encoded on its event horizon, a two-dimensional surface surrounding it. If this principle applies to the cosmos, then everything we experience as reality might be the projection of a deeper underlying structure. Evidence for this idea has surfaced in various fields of physics. Research into quantum entanglement, where two particles, regardless of distance, remain mysteriously interconnected, hints at a universe where locality is an illusion. Experiments studying the cosmic microwave background radiation, the afterglow of the Big Bang, suggest patterns consistent with a holographic imprint of the universe's formation. Additionally, in string theory and quantum gravity models, the concept of a holographic reality continues to gain traction as a way to reconcile quantum mechanics with the vastness of cosmic phenomena. If the universe is indeed holographic, it radically reshapes our understanding of existence. It suggests that what we perceive as physical space and time may be emergent properties of a deeper informational substrate. This notion aligns with ancient philosophical and spiritual traditions that have long hinted at the illusionary nature of reality. More importantly, it challenges us to reconsider the limits of our consciousness and perception. Could it be that our very thoughts, emotions, and awareness are part of this grand cosmic projection? If so, understanding and harnessing this principle could unlock new frontiers in science, allowing us to manipulate reality in ways we never thought possible. From advanced computing to breakthroughs in artificial intelligence, the implications of a holographic universe extend beyond physics. They reach into the very nature of human potential and the way we interact with the world around us. As science continues to explore the relationship between mind and matter, growing evidence suggests that human consciousness may not be separate from the universe, but rather an intrinsic part of its structure. Quantum mechanics has already demonstrated that observation can influence the outcome of physical events, as seen in the famous double-slit experiment. This raises profound questions about the nature of consciousness and its role in shaping reality. The idea that the universe and consciousness are interconnected is further supported by research into quantum entanglement, where two particles remain linked regardless of distance, instantaneously affecting each other. If such a mechanism operates on a fundamental level of reality, it could imply that our thoughts, emotions, and awareness are similarly entangled with the cosmos itself. Some physicists suggest that consciousness may be a fundamental force, woven into the very fabric of space-time, rather than an emergent property of the brain. Ancient philosophical traditions have long proposed that human awareness is a reflection of the greater whole, mirroring the interconnected nature of existence. In modern scientific discourse, theories like panpsychism suggest that consciousness is not exclusive to biological organisms, but is a fundamental aspect of the universe. If this is true, then our perception of reality is not merely a passive experience, but an active, participatory engagement with the cosmos. Understanding this profound link between consciousness and the universe could unlock new frontiers in both science and personal development. It could lead to advancements in artificial intelligence, neuroscience, and even space exploration by redefining how we approach the very essence of life and intelligence. If we are, in essence, expressions of a self-aware universe, then our potential is not bound by the limitations we have traditionally imposed upon ourselves, but instead extends as far as the cosmos itself. Many revolutionary ideas were initially ridiculed before reshaping science. Throughout history, new ways of thinking have often been met with skepticism, resistance, and even outright hostility. Galileo's assertion that the Earth orbits the Sun was condemned as heresy, yet it ultimately laid the groundwork for modern astronomy. Einstein's theories of relativity were once considered radical, but have since become foundational principles of physics. Even the notion that microscopic organisms cause disease, a concept we now take for granted, was initially dismissed by the scientific community. Every significant shift in human understanding has faced opposition, yet time and evidence have proven that progress is born from challenging established beliefs. The ideas that push the boundaries of conventional thought are often those that unlock new frontiers of knowledge. The question we must ask ourselves is, what modern theories and discoveries are being dismissed today only to be accepted as undeniable truths in the future? If history teaches us anything, it is that the pursuit of knowledge demands courage, curiosity, and an openness to explore beyond the limitations of current paradigms. What seems impossible or fantastical today may be the foundation of tomorrow's reality. By embracing this mindset, we create the space for transformative discoveries that can redefine not just our understanding of the universe, but our place within it. Society often resists change, but true progress demands a shift in perspective. The inertia of conventional wisdom has always been one of the greatest barriers to innovation. Whether in science, technology, or philosophy, humanity tends to cling to familiar frameworks, hesitant to abandon deeply ingrained beliefs. However, every major leap forward has required a willingness to embrace the unknown. The transition from the geocentric to the heliocentric model, the discovery of quantum mechanics, and even the acceptance of artificial intelligence all faced fierce opposition before transforming our world. History has shown that those who dare to question prevailing doctrines often pave the way for the most profound advancements. Progress is not the result of passive acceptance, but of relentless inquiry, where the boundaries of possibility are continuously redefined. By cultivating open-mindedness and fostering curiosity, we ensure that the next wave of discoveries, no matter how unconventional, has the chance to reshape the future of our civilization. Will we remain bound by outdated models, or dare to embrace a deeper truth about our reality? The decision to move beyond old paradigms is not merely an intellectual challenge, but a fundamental shift in how we perceive existence itself. If history has shown us anything, it is that true breakthroughs come from those willing to see beyond accepted limitation. The mysteries of the universe remain vast and largely unexplored. Will we continue to dismiss what we do not yet understand? Or will we step forward into the unknown, ready to redefine what is possible? Technology alone is not enough. The consciousness behind it determines its impact. While scientific advancements have propelled humanity forward, history has shown that technology is merely a tool. Its true influence depends on how it is wielded. Nuclear energy, for example, has the potential to power entire cities or unleash devastating destruction. Artificial intelligence can revolutionize industries or lead to ethical dilemmas that redefine the workforce and human identity. It is not the technology itself that defines the future, but the intention, awareness, and wisdom behind its use. For civilization to progress sustainably, technological evolution must be accompanied by a deeper shift in human consciousness. Knowledge alone is insufficient without wisdom, and scientific breakthroughs without ethical consideration risk leading humanity down dangerous paths. A holistic approach, one that integrates technological progress with an expanded awareness of interconnectedness, will determine whether we use these advancements to elevate or endanger our existence. The future is not dictated by science alone, but by the conscious choices we make in how we apply its discoveries. Our unified physics could lead to interstellar travel, sustainable energy, and an evolved human experience. The exploration of quantum mechanics, relativity, and the structure of space-time has unveiled a new frontier, one where the traditional boundaries of energy, propulsion, and material limitations may soon be transcended. If we can harness the fundamental forces that shape the universe, interstellar travel may become more than a distant dream. It may be a tangible reality. The unification of physics, particularly in understanding gravity at both cosmic and quantum scales, holds the key to propulsion systems that defy conventional rocketry. Concepts such as warp drives, gravitational field manipulation, and quantum energy extraction could enable humanity to traverse vast distances without the need for inefficient chemical fuels. With access to limitless energy sources embedded in the fabric of space itself, we could free ourselves from the constraints of fossil fuels, unlocking an era of ecological balance and technological abundance. Beyond the physical realm, a deeper understanding of the universe may lead to an evolved human experience, one where our perception of reality expands alongside our scientific achievements. If consciousness and the cosmos are indeed intertwined, then the next stage of human evolution may not be limited to biological advancements, but also to an expansion of awareness. A civilization that masters the physics of the universe may also unlock untapped cognitive abilities, redefine the limits of perception, and elevate the collective human experience to a higher state of understanding. We stand on the edge of a new era, one where we redefine our place in the universe. The convergence of science, consciousness, and technology is not merely a possibility, It is an inevitable step in human progress. The question is no longer whether we will uncover the deeper workings of reality, but whether we will have the courage to embrace them. Will we continue to perceive ourselves as limited beings bound to a single planet, or will we awaken to the vast potential that lies before us? The choice is ours. The future is not predetermined. It is shaped by our willingness to explore, to challenge, and to evolve. If we dare to step beyond the confines of outdated paradigms and embrace the limitless nature of existence, we may find that the universe has been waiting for us all along. Our journey is just beginning, and the greatest discoveries are yet to come. The time for transformation is now. The discoveries unfolding before us are not just scientific curiosities. They hold the potential to revolutionize the way we live, think, and interact with the universe. Yet knowledge alone is not enough. True progress requires action, a collective effort to integrate these insights into our technological, societal, and personal evolution. Knowledge is only the beginning. Action and awareness will shape the future. Throughout history, civilizations have risen and fallen based on their ability to adapt to new paradigms. Today, we stand at the threshold of the most profound shift in human understanding. But whether we step forward or remain anchored to outdated beliefs will define the trajectory of our future. By fostering curiosity, open-mindedness, and a willingness to explore beyond traditional boundaries, we can bridge the gap between scientific discovery and practical application. What kind of legacy will we leave for future generations? The choices we make today will echo throughout history, shaping the world that our children and their descendants inherit. Will we build a society rooted in sustainable energy, limitless exploration, and interconnected awareness? Or will we cling to systems of division and scarcity that limit our collective potential? The responsibility lies in our hands. Will we choose a path of division and limitation, or one of unity and infinite possibility? The universe is waiting, not for a passive audience, but for active participants willing to explore, question, and create. The future is not a predetermined outcome, but a canvas upon which we paint our destiny. The time has come to embrace the unknown, to challenge what we believe is possible, and to step into a future that reflects the boundless potential of existence itself.